And I guess before we get into the intros, the agenda, I'm going to have a couple of housekeeping items. The bathrooms are through double doors and to the left. And evacuation route is through the double doors to the left and all the way down the hall. And forgot to mention, this is a brand new Beamex office. We've been here a little bit less than a month. And we'll have lab tours before and after lunch. So as far as our agenda today, we're going to have Chuck go through the Beamex Experience, and then we'll have Roy do Where Does It Hurt, and then we're going to take a break. The first workshop will be software with Ned and Roy, and then again the first lab tour will be before lunch. And then after lunch, we're going to have the pressure workshop with Roy, and then we're going to have a break, and then a temperature workshop with Ned and Roy. And then closing remarks and recap of Roy. Any questions? So I'm just going to go through a little bit about just a brief introduction of Beamex, then hand it over to Ned. Before I do that, though, I just wanted to say that this day is kind of for you guys. It is for you guys, so we want to keep this very conversational. And if you have something to say, by all means, speak up. We go off on a tangent. If it's beneficial, great. So, I mean, we have an agenda that was put together, but, you know, we can be flexible. So Beamex in brief, 50 years is coming up soon, next year, 2025. 14,000 plus customers over 140 countries and 12 offices globally. Our customers, the industries, as you can see up there, pharma, chemical, power generation, oil and gas, food and bev, service, and water and wastewater. A couple of blurbs here. 18 of the world's top 20 pharma companies use us in some sort of fashion, either hardware, software, or both. We serve the majority of Fortune 500 ranked companies within process industries. What our customers say, documented 75% savings, 30 minutes saved per calibration in this case, and improved efficiency by 50%. And this is a really good number, 1 year return on investment. So I'm going to turn this over to Ned.
Yeah, there's a few guys. There's a few guys here that were my vintage.
Thanks.
This is when I graduated high school, so our founders are a little older than me, but I probably have a sweater in the bottom of my drawer, close to that. But I think this guy's son is one of our programmers today, and when I was hired almost 30 years ago, Arrow was our president, and but these four guys started Beamex, and this was our first calibrator. It's kind of like you sell pie, Reese, so it was kind of like a primeval pie. It would generate or measure milliamps or volts. So what's interesting is they were technicians in a paper mill. So our roots are at the floor in a hands-on way, and really the vision they had even back then was, how can we do things a better way, faster, easier, make the technician's life easier. And we got into software early on with a little paper tape coming out of an Epson, I guess, predecessor to a computer, but it would spit out readings off the calibrator. So you can see the input value and the output value. And it was at a nuclear plant, they would tear that tape off and staple it to their paperwork to validate that what they wrote down is what was observed in the field. So I kind of wanted to go through on the table upstairs, we had some of our old calibrators. But there's that VA calibrator back in '75. Then we brought out really a temperature electrical calibrator. It had the terminals here. And then this is still a great calibrator if anybody has one, or you can find it on eBay. The pressure range is 0 to 150 psi, but it has 3 sensors inside. And the logic moves from the low range to the mid range to the high range. So it gives you, it's almost like a deadweight tester. It's really a clever calibrator. They still work, but if that pressure cell goes bad, it's no good. You can't replace it. So then we evolved to the PC and the TC, 2 boxes, and I sold these when I first started, and I've always told people, if you can sell those, you can sell. But good metrology, just all those buttons, it was weird. And then this really was the founder's dream, was the MC5, and it's also up there on the table. I know Antonio he still likes the MC5. They're still out there working. We still support it. But we went from 2 boxes, we evolved to 1. So it had everything. It has hard communication in it. Real basic, not full blown. So then we brought out our flagship calibrator, the MC6. And that's what we're going to show today. We've also expanded that product to where we have a panel mount version, intrinsically safe version, and the dry block, which you see right here. So all based on the same interface and logic, and also excellent metrology. I always tell people we're the most accurate calibrator on the planet in a portable design. You got to have lab stuff to beat our numbers. And in a similar way, we've evolved with our software. Our first software was called CalDB. It was DOS based back when Bill Gates was running things and Steve Jobs. So you can see there's an IBM PC running it. It was DBase. We were using DBase as the database technology, if you've ever heard of that. Then we evolved to Microsoft Access. We have a product called QM6. And it was pretty good, but it was real slow on a network. People were always complaining about that. And now we've come out with CMX, which I'm sure a lot of the room are familiar with that. We also have some folks using our new web or cloud-based product called Logicate. So we have 2 softwares that we can deliver today. So this gives you an idea of where we've been and where we're going. And we are continually developing the products, and our products evolve. And I think we're unique with the MC6. It was yesterday, right, Roy? We released firmware version 5.1. So the MC6 that we sold in 2012 that had firmware 1.0, it's totally different today. And the calibrator you bought in 2012 will run the 5.1 firmware. So we keep you up to date and modern. Same thing with CMX and Logical. We're continually updating those products. I think CMX we update once or twice a year. And Logical we're doing all the time. We're releasing functionality and improvements every couple months. So any questions on the product line? I just want to kind of give you a baseline of what we're doing. So I guess, Chuck, this is you. Dave, did we want to go around the room and do a quick introduction?
Yeah, I'm sorry. I just do that. I'll start.
Yeah.
My name is Dave Shanley. As I said before, I head up our sales efforts in the Southeast. July was my 8th anniversary, and what I'd like to get out of today is to just kind of learn all about what you guys do and hope they can have some knowledge imparted on me as far as some different ways of how you guys go about your day-to-day jobs.
Good morning, everyone. Welcome. My name is Tony Garcia. I just joined the family, so the Technical Services Manager. Represent CFG, the Calibration Solutions Group, and I hope you enjoy the session today.
Hello, I'm Chris Val. I am a client development manager, specifically working with Dave in your territory. So you probably have seen my emails or heard my voice on the phone. Now you have this up in the Facebook matchup. So if you need anything at all, don't hesitate to reach out. Yeah. Oh, and I've been here for about, actually, just over 18 months. So it's very nice.
Doctor?
Hey, my name's Roy. I'm Calibration Evangelist. I have no idea what that means. I've been here for about 15 minutes. And yes, sir, you're next.
Hello, everyone. My name is Moises Harari from Nutrient, out in Augusta. Recently moved into the area, so I'm originally from California. Process control engineer.
Culture shock. California too, yes.
Hi guys, I'm Tiffany. I'm the marketing manager at Beamex. I've been with the company for 4.5 years. So here to help you guys out, support you, make sure you're well fed and happy. So if you need anything, feel free to let me know.
How about Hydrocal?
I am Austin Mancillo from Hydrocal. We do process and lab instrumentation calibration, so pressure transmitters, everything you could possibly think of in water and wastewater treatment plants. It's my brother Mason, so we're from Hydrocal.
Jeff Casey from Georgia Power Company at Plant Bowen, which is just about an hour from here. I've been with the company 36 years today. Been using Beamex stuff for about the last 27 years. So I guess.
Good morning, everyone. My name is Antonio Vega. I am from Puerto Rico, live in Massachusetts for 13 years. And I started my own business 2 years ago using Beamex product. And I'm just focusing on calibration around East Coast, most likely. But if you guys live far as California, whatever, and you guys need me, feel free to reach out. So I'm here today just to share all your experience and everything. So nice to meet you guys. So.
I thought we were going that side. Okay. Hey, good morning.
Going down the line.
Yeah, I see that now. I'm Christian Alvarado. I'm with Glad Air Techniques, a pharma company, and actually haven't been using Beamex too long, but pretty intuitive to you guys' credit. Here with Israel, so.
Hi, my name is Israel. I've been with Glad for 17 years. We've been using Beamex from the beginning. I haven't done anything else but Beamex. I mean, I've used stuff before, but it's ingrained in my head now.
Good morning, my name is John. I'm an engineer with a pressure switch manufacturer in South Carolina. And I've been with the company 3 months, so I'm here today just to soak it up.
I'm Will Fisher, I'm with Beamex Systems. I do quality control and CNC programming. First met Ned, we were in a boy band together in the 90s. And decided to get serious and ended up coming here. So.
Hi everyone, I'm Rob, Will John. We're with Beamex Sensors. We do pressure transmitters, pressure switches. We do the level flow and other types of data acquisition and transmission. I think we're maybe a little bit different. We're using Beamex to help us qualify products on the production line, end of line calibration, quality cases. And the way that we got in was working for a European manufacturer since 6 years ago, and subsidiary in Italy was using them. So, funny how, the world comes around here now.
How about the Milliken contingent?
Hi, I'm Austin Bishop. I work with these guys. I'm talking about how to use this equipment, the temperature, pressure, flow, and equipment.
Thanks, Gary. Milton, Dewey Flint, we do chemicals. Beamex has made, cut my job over in half.
There's a case story in there somewhere.
Chris, I'm also Milliken, fairly new to all the Beamex stuff, so just want to learn some more about it.
Good morning, everyone. I'm James Wilson. I work with the electrical machine control out of Trussville, Alabama. I'm a 30-year retired. I was with the city of Atlanta for 30 years. I retired. We retired for 4 years. I've just been introduced to Beamex probably about a couple of years ago with Ned and Dave, and I think it's a very, very good, excellent piece of equipment. It helps my job, cut my job time in half.
Kevin McLean. I work for American Petroleum near Pittsburgh, Pennsylvania. I am a recent instrumentation tech, so I'm here to hopefully learn lots. Thanks.
I'm Brandon Collier. I'm instrument tech for American Petroleum. I'm here to soak in more knowledge and get answers to some questions. So.
I'm Reese Horton for an instrument company, and I do calibration at Gatorade Rise Baking Company.
And I'm Ned, been with Beamex 29 years. And I was selling for a rep and met Reese before that. So I've been selling Beamex or working with Beamex for 33 years, really. So there's something about it I like. But it's great to see you guys. It's kind of almost like a little reunion. I appreciate you so much. So I'm going to turn it over to Chuck.
Yeah, I'm Chuck. I'm the sales director. I've been with Beamex for about 15 years. I've always kind of been in a sales capacity, so I kind of look over the sales. We actually call ourselves North America, NORAM rather. So out of this office, we manage all of the United States and Canada. But I'm going to make this real brief. We need to get back on schedule. What I want to do is just talk about what makes us tick and where we're taking our technology. It's not going to be intended to be a Beamex commercial. One thing about Beamex is that when we look at evolving our company, we don't have to answer to stockholders. We're privately held. We're privately held by a family out of Helsinki. And our competitors and our partners have all tried to buy us, and I think they quit asking because we say no. So we want to maintain that ability to be agile and invest our money where we want to, and answer the market, not answer stockholders. So it's a really nice position we're in. This is on our website, and this is our we call it our brand, but it's really our strategy. Our values: openness. We want to be open to new ideas, transparent, honest, precise in everything that we do, accuracy, and be precision. That's how we build trust with our customers. And then enjoy what we do. Be engaging, be people focused, have fun what we do, and build good relationships. So that's our values, both internal and external with our customers, but also that's how we operate internally. It's a really great environment to be in. In our DNA, committed and true. This is we want to be true to each other, true to our customers. That's how we build trust with our customers. We want to be honest and open and live by a better way. I think what you'll find out as I get into this is that we want to make it, we want to continually evolve our technology and keep our customers on the cutting edge. And always open to new ideas, innovation. Our aspiration, what we want to do is we want to be the best. We want to be the best. We want to be the go-to company in calibration. We want to be the best out there, best of breed. Our competition is well behind us because of our innovation. We want to be the number one go-to technology company out there for calibration. And our purpose is to be a safer and less uncertain world. Measurement is everything. Measurement is all around us. It's around, the food we eat, the medicines we take, the water that we drink, the things we put into our body, the gas that we put in our gas tank. Everything is around measurement. It makes our life what it is today. And what we want to do with our customers is make sure that they are their measurement. There's little uncertainty in their measurement. It's accurate, and they're providing the absolute best product. It's safe, high quality end products. That measurement is all around us, and it will make it a safer and less uncertain world. And that's all around measurement. That's all of our portfolio that's our sole focus. We don't get into anything else. It's all around metrology-based calibration software, metrology-based calibration equipment. So how we make it a safer and less uncertain world is our ecosystem. And we refer to our ecosystem. So what an ecosystem is it's units or components that all act together. They work together as one system. And that's the way that we look at our company. You'll see this on our website as well. And this is what we look at as our ecosystem. So we've got calibration management, which is how we digitalize our calibration procedures, get them into a database, manage that data. Our field calibration is where we're actually capturing that data digitally out in the field, untouched by human hands. Then all the services around that, there's a lot of services that make sure that we deliver and implement and train and make sure that our technology is delivering the value. When it's sold to you, we need to make sure that we deliver the value. And those expert services that we provide make sure that we deliver that value. At least safe environments, absolute most efficiency in your processes and tasks that you do to maintain your assets. And also compliance. There's different industries have different compliance requirements, but we need to make sure that that all of our customers can meet that compliance. I'm going through this pretty quick. So what makes our ecosystem unique? And this is really our differentiator in the marketplace. This is what differentiates us from our competitors. But secure digital data, the data is critical, and we need to make sure that it flows through our ecosystem efficiently and accurately, and it's secure. The data is number one, and you'll see that it's becoming more and more critical. Collaboration. Our customers, they have a lot of suppliers, they have a lot of vendors that they work with. Internally, they have a lot of groups that need to collaborate and share that data. So we need to make sure that we provide a platform that it allows our customers to collaborate with each other. Sustainable. This is becoming more and more of a talking point in the industry, and it is with us. Our owners want us to make sure that we're sustainable in the environment, and our technology is sustainable. That's our R&D investments, making sure that we can continue to deliver the value. Calibration excellence. We talk about calibration excellence, and so our customers, they can have a good, solid metrology-based calibration program. I've been with the company long enough. I've seen it many times where a calibration program, I can sit around a table of guys and say, hey, explain your can you describe your calibration program? And they kind of start looking around at each other and kind of snickering a little bit. The calibration program is in shambles. And what they can do is they can implement our technology and go from nothing to a world-class metrology-based calibration program. That's calibration excellence. Being able to have the data accessible, generate the reports, capture the data. That's calibration excellence. That's what that ecosystem that we have delivers. Guided calibration. This, you know, a lot of our customers, you know, they don't have, you know, it depends on the level of sophistication in particular industries, but they don't have a lot of their competence is, we can move a lot of the competence from the people into the technology by letting the technology do a lot of the work, applying a lot of the metrology, the uncertainty. A lot of technicians, they don't really understand uncertainty. They kind of have an idea, but this guided calibration takes that out of their hands. They don't really need to worry about it. They let the technology do it. And then data-enabled decision. This is also, data is becoming more and more of a focus, being able to make decisions based on taking this data and actually being able to derive some intelligence out of it. So that's what this ecosystem delivers. That's what really makes us different. You know, we don't really have a lot of competitors that can compete on all. These are the themes that we use when we look at our technology roadmap. And this is what we've got to maintain, and to maintain our competitive advantage, and also keep you guys, our customers, on the leading edge. So we don't want to sell a solution to a customer as a snapshot and say, hey, this is your solution. Implement it and, you know, go get them. It's a journey, really. And what we want to do is we want to be on a journey with our customers. We want to manage the calibrations. Manage calibrations, get the data, you know, the what, when, how part of calibration. Executing calibration, the field equipment, digitally gathering the information, executing that, analyzing the data. Once we have the data, and then we can start really doing some slicing and dicing of the data and make some good data decisions based on company. And this is a big part, improve, continually to improve. And that's another thing that we have to. This is a journey of improvement with our customers. It's not a one-time thing. We get feedback from our customers. We want to improve your processes. That's where we spend our R&D dollars. I'm talking really fast. With regard to our technology roadmap, this is one. So we have these environments that we have that our customers in. We kind of come up with these 4 environments that we have to consider. This first one is an OT-centered environment. It's operation technology. That's the PLCs, the instruments, the calibrators. So it is, and a lot of our customers are here. This is where we have maybe CMX on a laptop is not really sanctioned. You know, we get a lot of. I don't know how many times I've heard, hey, you know, we don't want to get IT involved. It's operational technology, and it kind of keeps it at the plant level. And a lot of our customers are there. They have a database on a system, just local. They don't want to get IT involved. A lot of our customers are in that OT-centered environment. Then we have then we get IT. We have some customers that have their OT operational technology environment. But then they have some local IT resource. Maybe they have CMX on a local server at the plant level, some IT kind of supporting it. So we have an IT and an OT type environment. A lot of our customers are here. I would say these first 2 are a bulk of our customers. Okay. The third is where we have a global engineering group, and they're going to mandate calibration processes. They're going to mandate, this is how you're going to calibrate across the whole fleet globally. This, you know, it's sanctioned by IT. IT kind of has control of the database side of the solution. The calibrators are still kind of operational technology. These are, you know, primarily you see this in pharmaceutical. We're going to have these global engineering groups. You know, a lot of, you know, petrochem, oil and gas. They're going to mandate how are you going to work. And so they have CMX installed, and they deploy it out either maybe through a private cloud or Citrix and make it available. So it's an IT and OT. This 4th environment, this is, I don't know if we have any customers in this environment. This is where IT and OT are converging. And if you look at the, you know, McKinsey reports, you know, they'll say this is the 4th industrial revolution, Industry 4.0. This is where IT and OT are blurred, they come together, and it's all data. It's all data driven. data-enabled environment. This is where it's going. And so this is where we're having to sit, we're looking at this and we're talking about this and how are we going to support our customers? Because not near term, but probably everybody in this room at some point, they're going to be here. And what we're doing right now is we're thinking about our technology that is going to support that environment. These environments will never go away. So we'll also have to, our technology will have to still support this. It's not going away. But we have to think about the future as well. That's what we're doing with our R&D. So we have the field calibration. This is what when we think about our R&D investments and our technology roadmap. The field calibration, that's never going away. And we got these out in the field, these guys clipping onto the instruments and doing the actual calibration work, capturing that data digitally. So we need to think about how are we going to do that in the future with this Industry 4.0. The calibration management, that's getting the data into the database, being able to access that data, be able to generate reports, being able to analyze that data, manage the data. So we also in that 4.0 environment, we need to think about that in our technology roadmap. So we got a lot to think about. And then of course the services, our services have to evolve as well. And they'll become more and more critical, particularly when that competence of our customers, they may not have that competence on staff. And so we, with our expertise and services, help implement it, train it, database migrations, those services that are around our ecosystem. How am I doing on time? So we look at the portfolio or our roadmap, and we have to look at maintaining our current technology and also the technology of the future. Now, CMX, the MC family of calibrators, and then all the accessories, it's a very healthy business, and it's delivering a lot of value for our customers. And we will continue to evolve that. We have to, based on where these environments are going, where the industry is going. And of course, our expert services. We also have to think about the addressable market in the future. If those four environments, if we just focus on one or two, we're leaving out half the addressable market. So in our technology roadmap, we are considering that. This is where Logical came out. This is Logical is our cloud-based solution, and we didn't take CMX and port it to the cloud. We built a whole new platform, software as a service. CMX is going to be it is for those environments that will really never touch the internet. So CMX, as far as security, CMX is installed on a network and in a network, and that network is secure. CMX, the way that it's designed itself, is not that secure. It has to be installed in a network that is secure, and this will be nuclear power plants, gas distribution. These where its supply is critical, and maybe even national national security issues like water and power. So these CMX, and we'll continue to evolve that, but that's really where we see CMX going. It's going to stay in a non-internet type environment. Logical was developed in this, it's a cyber secure just by design. We hosted it, and a lot of customers are putting it in the sewer, and the cybersecurity is built in by design. So we're kind of starting to address that market. B-Mobile, it'll talk with CMX or Logical. And so B-Mobile is really going to become the app that we started introducing a lot of the other things, and addressing additional, the killer apps. Maybe getting into, we're looking at, this hydrogen, where, different applications, valves. So we can start introducing that. B-Mobile platform is going to be going to have to get a lot of our R&D investment. R&D is working on as far as what are the evolution of our products. If like Ned's, we kind of showed the evolution of our products. And we're not putting lipstick on a pig. We're really coming out with some good technology to help our customers achieve what they need to achieve. So what we're doing with our investment is we're splitting our investment. We put about 10 to 12% of our turnover back into R&D. And that it's been that way since I've been with the company, and will continue to be that way, which is a pretty big number. But what we have decided, we are going to put 50% of our R&D investment into our existing technology. It's not going away. We've got to maintain it. And we'll continue to evolve it and make it better and evolve with these new environments that we're seeing. And 50%, we're calling this evolution and maintenance. And then 50% of our R&D is going into revolution. So we're going to start looking at new technologies to address this industry 4.0 that eventually I probably won't still be working, but when we get into 4.0, I mean, it will be a completely different environment. So as far as calibration management, like I said, CMX, it'll continue to be in a non-internet type solution. When we first came out with Logical, our thinking was that, you know what, CMX is going to eventually go away and everything is going to be Logical. But now that we've got it out for a few years, we're thinking, you know what, that's not going to work. Because of what I just said, CMX really needs to be in that internet, that non-internet environment. So they will continue to evolve. They'll have different use cases, but they'll do the same thing. So we'll maintain in both of these. I've talked about cybersecurity, which is going to, it's here today. Cybersecurity is on everybody's mind. And you know, CMX, particularly with B-Mobile, CMX, what we expect is it'll become more of a back-end type solution. And technicians will never even see CMX. They may not even work in CMX. We'll be downloading to field calibrators or B-Mobile apps. And it'll be more and more, we'll take away that graphical user interface. We'll move to more mobile platforms like B-Mobile is. We'll improve checklist items, both Logical and CMX. Logical, really what we're doing is our customers, our early adapters are giving us input, and we're directing Logical. It's kind of morphing into what does the market need. So we're using our lighthouse customers to really help us with Logical. So that's kind of what we're doing on the software side. Nothing is going away, but we're going to have two different paths. And actually, there will also be a path to go from one to the other. So we need to start building in that ability to kind of switch from one to the other as well. As far as field calibration, you know, what we have, when IT and OT start converging, you know, IT wants to manage, a calibrator is an OT device. It works on the operational side, but it has a user interface, and it could connect to the internet at some point. We just rolled out Bluetooth for the NC6. So now then IT wants to own it. Since it's got data and it's connected to the internet, then IT is saying, hey, we need to manage. This is an IT tool, not an OT tool. So what we really need to do is there's two things: is we can take out the internet access for the MC6 and it would just be a standalone device, or we can say, okay, IT, you own it, and that neither one of those will work. What we need to do and what we're looking at doing is separating the user interface and the measurement, and separating those two. And the user interface, the data side, can be managed by IT. And the measurement, the simulation and the measurement of process signals will stay on OT. So what we're looking at is how are we going to separate those two? MC6, again, is not going anywhere. I know a lot of our customers are saying, hey, you know, what's the next generation? You know, am I going to have to get rid of my MC6? That's not going to be the case. MC6 will continue to evolve. We will dedicate as much of our R&D to the new stuff as we are to our existing portfolio. And I think that's all I have. Sorry for going so quick, but I was trying to get caught up. Are we caught up?
Nailed it. To the minute, Chuck.
Oh, wow.
Amazing.
Okay, yeah, I hope that was helpful. That's really what makes us tick and where we're going with our technology. And it's all about you guys. So I hope that shows. I got there were some real good positive comments on our technology, and that's great. I'll pass that on to R&D. But I'm going to turn it over to Dr. Roy.
Yeah, that's a really bad idea. Thank you, Chuck. So I need to explain a couple things. Not really sure why I put this up here. This was like a lot of months ago, and we were coming up with topics, and for some reason I had to, where does it hurt? Okay, I have some idea, but we will cover that. I need to, I should probably apologize right now, because I'm probably going to offend somebody at some point today, so I'm sorry. Wait, does that work now, or do I have to?
You'll do me several times.
Yeah, okay. And one other thing, I am socially awkward, and I'm really not sure why I'm up here, but probably shouldn't have said that either. I used to work for the competition. Can I say that? I have witnessed the calibration company go from #1 to out of business. And it was interesting. I started out as a calibration technician in Colorado. Then I went to a company called Honeywell Loveland, and I was a database developer and a trainer and did support. But I got a unique opportunity that I could go into the software, and if I saw technicians struggling, entering something, or clicking 3 times when they should only have to click once, I could go into the code and change it so you could just click once. So I have a low tolerance for inefficient code or workflows. So I have a highly technician-centric focus. Everything when I'm doing a training or doing a talk is for technicians first, and then everybody else. Back to the company going out. Before Honeywell Loveland, there was a company called Loveland Controls out of Loveland, Colorado. That's where I'm at. They made a calibrator, and they made calibration software, and nobody really knew how big they were. Honeywell figured out how big. They figured out that this little company was the #1 in the world. So they bought them and then put their name on Honeywell Loveland, but then they didn't support them. They didn't put that R&D money that you heard Chuck talk about, the 10 to 12% annually. So I saw it actually go from up here to dwindling down. So Honeywell Loveland got shut down, and they said, okay, you're going to be laid off in a month. But my boss at Honeywell introduced me to the president of Beamex, and it was a completely different experience. So I ended Honeywell on a Friday, joined Beamex on a Monday, and when I tell you going from like an R&D of 1 person to Beamex, where I don't know what it is now, it's over 20 people just in R&D. Instead of just riding this thing into the ground until it didn't exist anymore. So I'm really happy to be with Beamex, and it means more, I think, than most even know. Where does it hurt? The idea behind this was that in calibration, we have these things in your plant. You have things that you have to do. And one of the first things I noticed in training calibration and calibrators and software is that I would go into the instrument shops and they would say, Roy, we are 1/4 of the size that we used to be, but we have more calibrations to do. And that trend has not stopped. It's not stopped. The instrument shops are smaller, and you have more work to do. And in some cases, you can't even calibrate everything that you need to calibrate. And you're chasing emergencies, or oh, hey, we got a flare up over here, or we got this down, I need you to go do that, instead of getting a handle on it. There are some tools that'll help you get a handle on it, and it's from an analysis perspective. Ned has an example of bunch of analyzers that are, it's showing an issue. You look at the data, it is showing you an issue, and I want, when we get to that point, I don't want to tell you what it is, but I want feedback on what you guys think the issue is when we do show you that graph later today. Ned. One thing I didn't say was, Ned used to sell that Honeywell Loveland that I talked about before Beamex. And did you sell it when it was Loveland Controls before Honeywell came in? So that was
DOS 6.0, baby. It works as good then as what we're doing now as far as documenting the calibration.
So that Loveland Controls was the only other company that you could get here that made the calibrator and the calibration software. When Honeywell came in, they said, all right, we're going to stop making calibrators, and they started OEMing or private labeling Fluke calibrators. So I trained on Fluke for a decade. I'm telling you that because right now, Beamex is the only company that makes the hardware and the software that you can get here. There is one other company. It's in I almost said Japan. It's in Japan. It's in Japanese only. You have to know Japanese, and it's only sold in Japan. So I guess you got to move there to use it. So I just want to be correct. But so Beamex is unique from that aspect, and I really appreciate that as well. I'm trying to figure out whether I should mention my 7-second attention span or not. All right, I'm not going to bring that up. We're just going to. Oh, great. Ugly baby. My first trip to Finland, I joined Beamex. I go to Finland, and everybody's reserved. They have great senses of humor, but they don't draw attention to themselves, unlike somebody else that might be up here. But the Finnish culture is very reserved. They're very precise, but their idea of introducing technology is taking this calibrator and putting it in your hands, and then you get to use it or use the software, and you decide whether you like it or not. It's not about me telling you that it's the greatest. It's about letting you choose. And since I had been a calibration database developer in the past, I went into the corporate office and said, why are we doing this? Why would you do this? Why don't we do that instead? I want to be able to do batch updates and do these things. And one of the guys came over to me and said, Roy, I need to teach you about Finnish culture. When you tell somebody that something is bad or that something is dumb, you are calling their baby ugly. If somebody made that, whether it was an R&D and they're coding it and they're doing the best they can, and you don't know what you don't know. So has anybody ever heard that connotation? You're calling their baby ugly? I'd only heard it in Finland. So I said, okay, fine. Your baby's not ugly, but it's hairy. You have a hairy baby, you should still change that. And I'm not sure if they were less offended or not. But, I mean, hairy babies can be cute, like this little guy. And just because it's a hairy baby also doesn't mean it can't grow up to be a badass. I mean, that's a hairy dude. So all the MC6s, all the MC5s, all the calibrators that you've had have been made in Finland at one location. It's all under one building. All the R&D, all the work. Yeah, I just frozen up there. The factory is 3 hours south of the Arctic Circle. And in the winter, the daylight is what, from 10 a.m. to 2 p.m.? Otherwise, it's dark. But when you go further north, then it's dark even longer. So what do these have in common? A Bentley, an MC6, and a Nissan GTR. a Bentley is handcrafted. There are no robots that are doing spot welds. Everything is joined together. And when they're actually, when they do have seams, they'll put their fingers over it because you can tell your finger is more sensitive to an offset than quite a number of tools. The Nissan GTR, the engine is put together by hand. You have to be a master craftsman with the time period to become that is, I can't remember how many years it is, but you can't even do anything on it until you've been under somebody for 3 to 5 years, and I think it might even be 10. Everything's adjusted. There are no impact wrenches putting the GTR engine together. Everything is by hand. They're using torque wrenches, and what they found is that by doing it by hand, it can be twice as precise and get more efficiency out of that engine. And you can't really tell it right here, but that's a stamp on the engine. It says handcrafted by, and it's the name of that master craftsman that built your engine. So the MC6 is, okay, it's kind of exactly a Bentley or a GTR engine, but these are hand built as well. They don't go on an assembly line. If you order 2 of them, then you have one individual that is sitting there working on your calibrators, assembling them, and using precision and care. And then that individual, once they're done, they seal it up, and they walk this to the calibration lab and calibrate it. So I sent some words, and Tatiana threw up some images, and I guess he's matched pretty close. On the words that hurt, I want you guys to be prepared to interrupt me. I want some feedback on this. I want to know where it hurts for you guys. We all have pains that we deal with, and pains motivate us. And it might be part of why you're here, and it might not. But I want to know what the pains you guys have about calibration that you want to address, or some of your questions. So this is like a choose your own adventure. With that, would everybody like to start?
Well, we're going to have a pressure workshop, a temperature workshop, and a software. So, any of you guys want to see anything in particular?
That's true.
When we get into the
After this, we will take a break, and is our software up first?
Yep.
So we'll do some, and after lunch, we'll be doing a temperature and pressure. But it is okay if you guys don't have an example for this.
Well, it's an open invitation. I would think, as you get into the workshops, I imagine there's going to be some questions. Yeah.
I do.
Brandon.
Yeah. Implementing even low pressure automatic pump somehow into the MC6. I don't say that as in if you're going second level up by the ladder well, you have the MC6, and you have the wire going into the top of the pump, and you have you're carrying that in that on the ladder well, so you already have hands. And that's not carrying like stingers or stuff that they can do. They can press wrenches for the instrument that's up top. So that's my only, I guess, nitpick. It does get more difficult when you have to do stuff and have 2 different machines, even though the machine is an automatic pump. So,
Velcro.
It might be something I can stick something together, or I was thinking, it was just a thought. It'd be nice to mix a backpack, or even if it's an over shoulder one, where you can just stick them in there, that way you're able to climb with your hands free. We can use a radar.
Tiffany, write that down.
But there might be one where it's the pump, it's like on the side. It's clear still, so you can still see it.
You don't have to keep taking it in and out of the bag, just to do it, set the bag down and get to each one of them.
All right. Good, I see Matt writing back there. Thank you for capturing that.
Kind of second that, and funny enough, because I had similar pains. The automatic pump's great, but it is heavy. I thought this was low hanging fruit, not like too simplistic, but why the asymmetrical strap? Like where it dangles, I actually find that more of a hindrance when I'm in a position like that.
How do you take it off?
And I don't like how it's asymmetrical, because if I'm in a weird, if I'm in a weird position, it doesn't sit on my body well.
Really?
And practically speaking, yeah.
You know what? I had the same exact thought. I said, what the heck are you doing? Because oftentimes they show flat like this. So the purpose of the strap is that you can hang it from something, and if it's leaning against it, then it'll be flat. But if you put it around your neck, it's pretty easy. Yeah, see, I can't even do it there. It is designed to do this. If you shorten it up, it'd be like this. But are you saying it's hard to?
It twists. So I mean, do you have that?
Yeah.
Mine usually twists out of like view, and I'm on
Mine
a ladder.
mine does every time. So what I do is I just put it there and just put the strap on top of it.
Around the back.
Yeah, the back, just to keep it straight.
I kind of have to like.
Because another thing is, if you, I literally, as soon as I walk to an area that I'm gonna work with 10 instruments, 10 pressure transmitters, first thing I do is I look where I'm gonna hang my calibrator. That's the first step, you know? So sometimes I hang my calibrator and because twist, it hit the isolation valve or manifolds. Oh my goodness. I looked at the screen right away, so lucky me, I don't crack the screen. So that's definitely a pain.
So I think that's a cool idea, like a holster or body holster kind of thing, because like, I'm going up on a fluid bed and there's like maybe 1 story, 2 story high on the ladder. You know, they don't always have the best ideal positions that you're going to be in.
So are you after mainly something that would help the position of it stay put, or
Yeah,
a better thing to hang it on something?
Both, or just making it accessible like on the practical sense. It's a great device. I mean, I love it. But I want to keep it. I want to keep it intact and while not compromising my safety going up.
Do you guys always use it like that way, like the way he's handing
I
it?
do the same. I sometimes hang it, but I don't like it.
Because I never use it
treat
that
with
way.
reverence.
I
don't
think it's
wanna-
my belly don't allow me to. That's maybe for
If
skinny
you go
person,
high
you
enough,
know?
mine's a shelf. So.
The thing is, if I put it here, it's gonna be far away from me.
It's easier to hang.
Heck, oh my
Yeah,
goodness, all the
usually
time.
behind it.
When
100%,
it's hung on something.
But I don't
Like
like
I said, I put the strap behind the right corner,
Exactly.
so it stays
Straight,
flat.
yeah.
But
Yeah.
even if you put a clip on that side that holds the strap there, that would break up and hang it on something.
I think we lying if like, I don't know, if you didn't attack or like, that like you've ever dropped a meter up once, and I don't want to do that. So I'll always say treat it with reverence. So I want to make sure I'm not putting it in weird positions.
All right, I don't really want to say this out loud, but I actually agree with you guys.
Even sometimes when I'm in a ball, what I do is I just take that strap, kind of hang it over the rungs of the ladder itself, and kind of let it sit flat. That's what I do most of the time.
Except, I did have somebody put something here that would actually hold the strap so that it was more on the top, so it was more predictable, I guess, when they were hanging something. But these are good ideas, because this is all real world application stuff. Any other comments on the strap or the hand grip? One other thing, occasionally you may have to swap a battery, and the calibrator does have to learn a new battery. It's a lithium ion, and to get to it, you take this kickstand right here. There's 4 screws under there, and to get the kickstand off, it's up, down, up, down, and then over, and then that comes off. So I'm pretty sure that we have that on the website somewhere. Comment, or you know what? If you're like Ned, you can just I don't know, do that, and it'll come on. How we? I think we're. Roger. Just making sure you weren't giving me that signal. All right. So, feedback on that. What about the pressure ports? They're pretty good. Are any of you using the external pressure modules?
Yeah, we are.
Is it because you don't have enough, or because you need a higher pressure than what this can hold internally?
High pressure. And for the pump, like we do low pressure switches, slow make break, so we try to utilize the pump. Again, communication with the pump with MC6. A lot of times we need it to pump it up slow, and then it records the switch opening and closing, but in other times, we needed to release the pressure all in one sitting as slow as possible. Remember, we're doing those pre-action switches, and the contact barely even touch, and then the pump will start to kick back on, change the history switch. Something that we wish would be a little more programmable, but we use the external pump because I can control the pressure, 0 to 3,000 water wheel, the alcohol water mix, and it's just. I'm in control of the ramp up and the pressure release, so it works good.
Do you have much control with those two fields that cover the ramp and
It's kind of a niche thing, and it's something that we just found out.
The ramp thing is, we can hunt for the switch. We have a routine that will go to a max.
Pre-scanning?
Go to a max temperature, pressure, and just make sure the switch actuates.
Yeah.
And then we start hunting for the set point. And we've got this algorithm that does it, but I think it's easier to just do it manually than let it do it automatically.
It's the slow make break volume.
Yeah.
Of course, as soon as the contact barely goes like here and all that stuff. Manually do it, just.
Step, we need like a damping or something.
Well, they evacuate the pressure out, so it's smooth and cool.
Is there any word on, an automatic high pressure pump coming out?
If we could set the cap one, that would be really interesting for us.
we have an option, it's just not really affordable. So this will go up to 3,000 PSI. We have one customer that puts it on a dolly with a mini nitrogen bottle in Kentucky.
I think R&D is looking at that, because when we came out with the EPG, that was the first feedback we got was the high pressure.
How high do you need?
Usually like 3, is what I call it.
3,000.
But I mean, that's fine. You can match it up with the Beamex. It makes it more precise.
I've been thinking on his problem that with the EPG. Another, maybe something you guys can think about it is just make the communication cable longer. Because I just run this kind of similar issue that the pressure sensor, it was a capillary one, it was far away from the transmitter. So what I did was I just grabbed a piece of like long tubing, I just connected over there, run it near the transmitter, and obviously using my pump, I pump it up and I did my calibration. But it was up to 150, so I have to like bam, 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 bam there, for half an hour or so. But luckily it wasn't a like a high pressure or something, because I don't have the EPG, because if I do have the EPG and then I have to connect it over there and you be close to the transmitter, then you don't have enough cable to connect it to the EPG. Might be a problem at some point. Like for the example you did, you say you have the transmitter up there, but you have to carry your pump and your calibrator, and if you maybe left put the EPG down in the ground, just run a longer cable, you have your calibrator there, so you can do the, I don't know, I'm just thinking.
All right, thanks, guys. Just making some notes. Anyone else?
When you use it as a benchtop device, it'd be nice to be able to just take that strap off. It's just one more thing that's cluttering up your bench, and you got wires and cables and tubing going everywhere. It'd be nice.
Is this still room? Oh, yeah, that plastic piece on there now. All right, I have to admit, on the previous read of this, I did take my strap off too. All right.
We could put a clip on it. We could have clip strap.
All right, noted. Okay. If you guys do think it's something else, it doesn't have to be right now, you can bring it up later. That is just fine. Let's go ahead and take our break. And be back.
How long?
At
We'll be back at 11.
11. Okay. seen you all before. Anyway, so yeah, I'm Roy, this is Ned, and you already knew that. We're gonna talk about software now. So, did I even make this? So, software topics, B-Mobile, I'm just gonna call it the app. B-Mobile is the thing that runs on your cell phone, it runs on your tablet, it'll actually run on a PC as well. So it supports iOS, Android, and Windows 11, and 10 if you're still running that. So the app, anytime we say the word B-Mobile, this is the app that we're talking about. This is another way to enter data. This is your electronic thing to avoid you writing down on a piece of paper. Back when I did calibrations, I had my mechanical pencil, I had my clipboard, my paper, my scientific calculator. After every day, you have to, well, more than likely transfer those numbers into something else, into a primary document. And the more in a hurry I was, the poorer my penmanship would become. I don't know if any of you suffer from that. But the day's not over when you actually are done with your cals. You gotta go. Hey, easy. It was probably closer to that big cheap tablet and the big crayon. Yeah, okay, fine. We're going to show you a couple examples. One of them is a pH. That'll symbolize any analytical test. We have a pH test where we'll be using a buffer solution and comparing that buffer solution of a known number to a number on a display somewhere. Or if it's a pH transmitter, you'd have a milliamp output. It doesn't matter. And a checklist. If you have a responsibility for following a certain series of steps and documenting the fact that you followed them, this is what the checklist does. It makes that electronic as well. I should probably give you this. Seriously? Tatiana, did you put this in here? The BYOB, what does that have to do with it? Oh, bring your own browser. Okay, fine. Software, there's a browser-based software. That's what we're calling Logic Count. And that means you don't have to supply any server, any hardware at all. If you don't want that, then you can bring your own server. And this is that inside the network thing. So CMX, if you wanted to run that in-house, whether it's on one computer or you have that in the server. But CMX, it's also possible to put CMX on the cloud. I probably shouldn't have said that. We have a couple customers that have it on Azure. They're also running it on AWS, so it is possible to put CMX on the cloud, but that's with your IT department to set up. We're more than happy to share the knowledge of how to do that, but your IT are the ones that would do it. Is that fair? And other topics, whatever that means. So let's bring up B-Mobile. It's not lunch. Do not read that. So this should bring up your B-Mobile app.
Oh, this is Logic Count.
That is no worries. You have like 18 things. So this app that you're seeing is the same thing that runs on your phone or your tablet. It just runs on the Windows as well. So this operates in an offline fashion.
So this same app runs on your phone. So it would be, it's kind of like using map software where you have to look at it narrow, or you can turn your phone sideways and look at it.
Yeah, and apologies, you can't really read this, but this is the same content, the same information that Ned's got up here. It lists individual assets that you will be calibrating. Let's do.
Here's pH 1000.
All right, fine, let's do that.
We were supposed to do that 6 months ago.
Are you 6 months late?
Also, when I logged into the app, I'm Peter Parker, in case you didn't know. But I highlighted this tag. It has some instructions. So So James, you always make sure your buffer solution is fresh, correct?
Correct.
Yeah. You don't need to be told that, but you can have messages. And this is kind of our overview screen. It's letting you know that there's some kind of analog signal between 0 and 14 pH, which is a buffer solution, and then you're going to key in a number versus that buffer. And effluent pH, so this is the fallout somewhere. So here it says our nominal point is 4, and we should see a readout of 4.
Before you punch anything, let's identify our references. We do want to note that we used individual buffer solutions and what batch numbers that they came from. So we'll hit references. And you could do individual points. Let's leave it on all points though and hit select. And if you didn't have it right here nicely like Ned, you could just type in pH and it would find your pH buffer solution. So you click that, and he's got individual modules that are 4, 7, and 10 pH. And he's got, in place of the serial number, he has the batch number of the solution. And then he'll put in the due date of whatever, well, the expiration date.
But since we're going to do all points, we'll say we used all 3.
Perfect. Hit OK. All right. So that scaling is interesting. Can you maximize that window?
Oh, that would be good.
Because normally it's going to show you the entire graph here.
So we're going to pull the probe, rinse it, and put it in some 4, right? And then we're going to look at the display.
And our display is showing 4.02. I just made that up. All right, so graph it, and then we'll hit this green arrow to go to the next test point. 7. Do you have a 1 pH tolerance? Go to 7.2. All right.
It's actually 0.3.
Oh, is it? Okay. And if we wanted to, and it was allowed, this little, this is called, this is a skip point. If you were set up as a 5 point, but you really were only going to do 3 of them, this is a skip point. But this is, go ahead and go to the next one and start filling in. This is assuming that you're not in a regulated industry like pharma where you're not allowed to skip test points. But here, you have the freedom.
Still reading 10 point something?
Yeah.
You want to pass or fail?
1. And I realized we did 2 decimals on the first one and 1 on the next 2. All right, so we know that we're in a passing situation. The blue lines represent your tolerance no matter what. It's just auto scales. Let's go to the next step. Passed. Maximum found 0.2 pH. Let's go individually on these. So we have the chart.
Already saw that.
Point details. Numbers, and then the environment variables are able to be filled in if it's important to you. If you don't need them, then don't fill them in. Don't take that time. Like the ambient temperature and humidity. And free fields, do you have any on there?
Yeah, but I think they're...
In CMX, you can bring over free fields in CMX and bring them over to your calibrator or to your app. And they just aren't named here, but you can name them as well. It could be anything you want. All right.
You also can type a note. How do you want to do it?
I'd like to know from a show of hands that at this point, who would save it as found and who would save it as both? Who would say this found? And who would say this book? And I didn't mean for this to sound like a right answer, wrong answer, because either one of them are legitimate. And I can tell you, I thought that when I joined Beamex, because I had never heard of saving something as both until Ned. And Ned is the reason this exists in your software, so thank you, Ned. Save it as both. Make
I
yourself
thought you could change the code. I thought you,
Yeah, that's,
How come sometimes you can save it as good, sometimes it doesn't quite update?
Yeah.
Like,
So-
here's what as found, or as,
so why does as both not always show up?
yeah, I would say in a regular Beamex, like after you test something good, it passes. Like, you know how they light up, so they don't, the as good doesn't light up sometimes. It's just,
it's probably a setting in your calibrator. There's a setting in the software and the calibrator.
Just to allow it. The default is to not allow as both on your software and hardware. You have to go in and make sure they're enabled in both.
okay.
So, in all of your MC6s, you
We
guys.
could show you the breakdown.
All right. So we did another one before, but here's our pad, or did we? No, you saved it as both. What am I saying? So we're done. And at no point did we have to write down anything. So that's the value of an app. The app is good for things you can't use your calibrator for. While you can key in stuff, you could actually do your pH test on here and manually key in what the pH values were. But the app frees up your MC6 for somebody else who actually needs it, maybe to perform a transmitter count. So this gives you more flexibility. Checklist. Can you
One
bring up-
other thing related is we're bringing out Bluetooth. Chuck mentioned it. But we're gonna have, you can get a dongle that goes in the side here, just like a mouse dongle. And through the Bluetooth connection to the tablet, you'll see the MC6 readings. So instead of you having to key it in, it's just another way to work with MC6 instead of on the screen here. So Antonio, you could just have your tablet and be talking to your MC6 down on the ground while you're up over by the PLC or whatever. Via a Bluetooth connection.
Can you generate certificates off of this? And what you would generate software?
Well, you would upload this past result.
Yeah.
You would upload this to
CMAX.
CMAX just like you're doing with.
Okay, but you can't generate specifically from.
No. So the B Mobile, just a data capturing tool. All right.
Anything that you're doing manual entry now in Logical or CMX, you could be doing it here. Bring up your PDF. Do you have that?
Oh, yeah.
I want to see a photocopy of a photocopy of a photocopy of an old checklist from 1952 that somebody had utilized. Oh, good. Here it is. Acme. So all the names have been changed to protect the innocent.
But you can see how fuzzy it is. So the guys handed me this form and they go to the copier and make another blank form, and then they make a copy from that copy and it turns into this. But
That's page 1.
then they have some reference documents. And then they show these 4 guys did the work. We have P and C, which is probably text, and
So-
then SIS engineer.
Is that a group of people going at the same time, or is it Tech 1 going? and
Yeah,
doing
it's a
it, and Tech
team.
2?
It's a team effort, yeah.
Team, okay.
It's like an interlock check, what I call an interlock check.
Checklist, caution, notes. Okay.
And then it's just following a recipe.
Conduct
This
the
is
physical inspection. I just complete the requirements of the pre-inspection checklist, conduct the physical inspection, place the solenoid bypass valve in the bypass position, and initial and check that you did it.
And it has place for comments, there's no comments. And,
Oh, here's a comment.
yeah, you can see it pretty good here. So yeah, there's no place to write comments. That says repaired air leaks.
I could not pick that up.
And then, so this TW, whoever was filling this out, was different than this DW. So this DW liked making a comment.
So how would you do this if you had another option?
I'm glad you asked. So I took that inspection and put it here in CMX and pushed it down to the cabin. So here's that same information that we saw that has their procedures and reference documents. So you can see all that, and it's a 19-step procedure, it's 19 tasks. So let's start. And make the pre-inspection checklist. You could write a note. Say updated. So you can make a comment, but you probably won't do that. But then you hit pass, and I've got it where it automatically jumps to the next step. So the next step is to conduct a physical inspection. You could say there was moisture. Then you're supposed to just place the solenoid bypass valve and then see what happens. Call the control room. Do you see it changing? Yes. So I'm just going to blow through these.
Can you make one of them fail?
I was going to, where did he write repair air leaks? This is step 14, somewhere around here.
He probably has it set up. So
here it is. Here's control valve. So let's say he wants to make the comment that he repaired air leaks. So you got to spell it right. So I said that step failed, but I still can say that since I took corrective action, that the whole inspection passed. So we'll get here. Test is complete. Complete the non-conformance checklist. Another check.
Does this ever end?
This is step 19.
Okay.
So I had 18 pass, 1 fail. I can write an overall note, but I have, so good or bad, this is how Beamex has set this up. You are the final judge. Did this task pass?
And that's because there's nothing to calculate. So you get to choose. You are the master of this info.
So I ran through those 19 steps. If I back out of here, it shows that I completed this on the list. And I can push this back to the software. If somebody wants to see a document, they can. You can also, you're capturing this data so that repaired air leaks comment, maybe a reliability engineer would be interested in that little failure. What you're bringing it to their attention. We got an air leak problem. And if you see that over and over, what corrective action can you take to prevent air leaks in the future?
Yeah. So just reinforce on the app, this data has to go somewhere else into one of our databases. So either Logical in the browser or CMX on your server.
And as an example, I know that Marathon, you guys do a lot of tasks like this. And rain or shine, hot or cold, you're out there with a clipboard filling out these forms, right?
Wait, you guys use crayons too? Is that just me? All right.
I mean, does anybody have like an SIS procedure they have to follow, safety inspection system? I don't know if we have any. I guess Georgia Power. This would lend itself to that. Those tend to be more complicated. This is kind of simplistic maybe. So I don't, it's not, our system, our solution is pretty simple. It's not complex, but we are looking for feedback from customers and we are improving capabilities.
Do you have so I guess qualitative data, right? Do you have an example of this in CMX, what it looks like?
Yeah.
The results? I'm very curious.
And does this checklist have to be done all at one time? Meaning, I can stop, do something else?
Yeah, say this.
If you go through and do 3 of them and you leave, when you come back, you'll say you have 3 done. It'll actually continue where you left off.
Oh, that's nice.
By default. You can back up again if you want to know.
Let me borrow your. So this is CMX. I'm in my Acme chemical plan and I have interlock checks as a node. So here's M&T 0255. So here's a work order number that I keyed in manually. And if we break this down to the different levels, this is the meat here. And this was 19 steps. So you're able to put in a header for these if you have multiple sections. And then you kind of have a short description and then a much longer description of what you're supposed to do. This is a pain to build. It's not, a lot of typing or cutting and pasting. If you can open up a Word document, you can paste this information in here. So that's how you build it, like that. And then you can see I've demonstrated this over and over. So let's look at this one from last year. I had one failure probably similar to what I just did. And if I right click, I can print a certificate. And let's, so what I showed you at the beginning was the old form. This, so to speak, is the new form. So it just shows the area of the plant. It shows that we had 18 pass, 1 failure. And then here's, I didn't write any notes on these tasks. And there's where I typed in repair your notes. Step 5.1. And Clark can approve this calibration or check. So you would have to put in the notes, if you had 4 people like I showed you, you'd have to put their names here in the notes here. So, but that's how it works. And instead of printing it out, it's always available, or I can create a PDF and file it.
It's always, the results are always entry field, not, you can't do like yes, no, kind of select button.
That's an enhancement we'd like to have. So instead of it saying pass, fail, it'd be nice to change that nomenclature to say yes, no for certain things.
Yeah, some things are fine.
We also would like to be able to key in numbers. You just make a note, you're entering in a note. Like you can say, like one example I have is a guy goes up to the 5th floor of the building and he looks at all the HVAC stuff and he writes down some temperatures or looks for water on the floor. Then he goes down to the 4th floor and looks around and just is doing a building check to make sure that nothing's out of line every day. So it's nice to record some temperatures. If you're looking at a transformer box, you might take an infrared gun and look for some hot spots. You could write down some numbers like that. So we need to enhance this a little bit, and you guys may have applications that do a better job for certain things, but I would say we do a better job than some other applications. So you can blend this into what you do. But I guess with GLAD, you guys have to give an overall inspection statement aside from the instrumentation.
Yeah.
So this might be something that you could integrate into your.
So we have CMX, so do we need anything else?
You do. You need there's a maintenance inspection option.
Okay.
The B-Mobile piece, you just need to have either you carry a laptop around. So you can go to the Beamex website and get this app. There's no charge for that. So you just need an option activation on your license, your CMX license.
And right now, this is a CMX thing.
Yeah.
So once the B node goes into the CMX database, right? It says this pressure transmitter was 1, 2, 3, 4. Now, if you test it like that with the B node, and then you test it with just the MC6. The MC6 certifications doesn't have like pass and fails. How many of it pass if you have 18 and 1? So the certificates are gonna be a little bit different, so you'll know which one apparently goes on.
No, they'll look identical. But if you used to be mobile to do the calibration, maybe you used a crystal pressure gauge and a Fluke 87 meter. Like you could use it with existing stuff. You don't have to have an MC6. When you use the MC6, it pulls in the MC6 serial number, its due dates, all that stuff gets pulled in automatically. So you don't have to sit there and pick it. But remember, I picked those buffer solutions. You kind of have to do that. You have to say, I used a crystal gauge for the input, and I used a Fluke 87 serial number, whatever, for the output. And that's the only way you could tell it was different, is that it had non-Beamex standards used.
Let's see the top on that. If you scroll over, it has the red pass.
Yeah, this form's a little bit different for the inspection. But yeah, since I remember at the end on the verdict, I said it passed. So that's why it says it there. But it's not showing up in red here where I said it failed. There. That would be nice to be in red, but our form isn't working that way. But if you did if I showed you the pH, let's see, close this. So if I find the pH 1000, so here's the calibration from March. So there's those 3 points. This one had an as found and an as left. It's different. But I can use the same template. The pH that Roy and I just did together, it has all the elements that you're used to. It has sort of the database, the graph, and then here's the numbers. And here, this one was approved by somebody. But if we zoom in, and see, I used HANA. It's a HANA pH meter, and I did not take the time to list the buffer solutions. So that was bad. Maybe I put it in the notes. There I go, lot numbers, 1, 2, 3, 4, 5. I just wrote the lot numbers down. So, and that is a pain. If you want to have the lot numbers on a pick list, somebody's got to put that into CMX. It's a pain in the butt. So this is an example where you don't have to do that. You could have a message reminding you to enter in the lot numbers.
On that theme, I think it's important that if you guys do make changes, that you don't end up making more work for yourself if it's not helpful.
Yeah. So for the B mobile alone, do you need any type of license things?
Just an option on your CMX license is all. But that's for checklist. No,
just the B mobile.
No, if you wanted to do a calibration,
yeah,
like the pH,
yeah,
no charge.
So do we need IT involved at all? I mean, do we just put it on our phone? I mean,
Well, would you key it into your phone?
yeah.
So then your phone's got to connect to CMX.
Okay.
So IT won't like it. Or they might like it, but you got to go through them.
Okay.
Because you got to join the
So
network
we do
through
it on
the
our
Wi-Fi.
Wi-Fi.
Like you'd have to be able to get on the company Wi-Fi.
Okay.
So actually, and this may be a multi-pronged question. You mentioned a Bluetooth adapter to the MC6.
Yeah.
So if I may present a PT100 simulation, right? But as a loop. So only simulating in, and then the HMI is quite a distance. With this Bluetooth, you can go there on your phone. You can still be transmitting actively, and since pharma's Alcoa, you want contemporaneous, you can go to the HMI and still get that measurement keyed in.
Yeah, but I think you're limited to about 35 feet.
Okay.
Bluetooth, yeah.
Still, it's still helpful though.
So you get some long leads at NC6.
I have good eyesight.
Halfway.
Yeah, I have good eyesight, but 35 feet might still help stuff.
Or you could even walk over there and then walk backwards close enough to key it in. I mean, but yeah, it's not perfect, but it's just another way to work is all it is.
So you can use that Bluetooth adapter and the Beamex app input in parallel with your
Yeah.
MC6.
Yeah, so you'd be seeing the simulated signal would be coming into the inputs value. You're just gonna be keying in the output value.
It would be nice if you're using the same example, you know. It would be nice if you can use B Mobile and just let your calibrator on the transmitter connected like to B Mobile, and then you can pick and choose what the calibrator you're gonna use, the reference, you know.
Yeah.
As soon as the B Mobile sees you are using the MC6, you know, and then link each other together, you know, start your test from here and grab all the readings, and then save it and just save it on your calibrator like remotely, you know.
That's what it'll do. You're
both
driving
connected to the
the
same server.
MC6 from the
B Mobile.
interface. That's how it'll work.
So recognize your unique, you know, okay.
Yeah.
And you don't need that adapter, the Bluetooth adapter, or you do?
You do.
Okay.
And we charge for that. You'll have to pay for the little dongle and the son of a.
It's no such thing as a free lunch.
So that was B-Mobile.
And some CMX. Now, Ned did say that checklist was complicated and just it's difficult to make it. But if you have 10 tags that have this, you can simply copy this tag and rename it to a new tag, and now you've already made your second one by just copying it. Or if most of it is the same, then it's still an advantage to copy it.
And if it's not too complex, we can import it.
Brandon?
If, let's say you're on the B mobile, your Bluetooth, your CMS, let's just say you're hooked up to a transmitter, which is CMS, and you get your map values you pull your map values off the transmitter. Will that go into B mobile? You know, like when you want to test it, it sets everything in there that it pulls. Will that pull straight to the B mobile app?
No, it's gonna pull it into the MC6.
Right. Oh,
And then when you execute the procedure, you're driving it through the B-Mobile app. Yeah. So it'll work the same, but instead of touching the MC6 screen, you're just gonna be doing it on the tablet or laptop.
What's gonna happen if you go out to the field with the V Mobile and let's say I set up something on CMX 0 to 100 degrees C and it's not degree C, it's degrees F, because you can't edit it on your V Mobile and then it will update it on CMX Pro later on, or?
I don't know if you'd be able to do the edit through the
V Mobile.
You might
Fix it first.
but it might work. But then I haven't seen it, so I can't say. But I would go to the MC6 and edit it there real quick, and change the range, change the test points,
Or CMX.
and then when you start using B Mobile, it'll work. Excuse me. I think next is Logical. We ready to change channels?
Change it. And just to make it clear, that B-Mobile app does work with Logical as well.
So I know we got at least one Logical customer here.
Who's running it?
EMC. And it took us a while to get it working. We had some bumps. How often do you use it now?
Every time I go out to customer calibration. Right now, it operates smooth since we ironed out all the little rough edges on it. it's something I love it now. It's much easier to go to a facility. And what I like to do is get all the information from the facility itself. At home, just put everything in there, download everything, and then go to the site itself so I can just push forward and just calibrate what needs to calibrate without having to enter the information and then go calibrate. And, that kind of takes up time.
So do you have to do a walk down, so to speak, or can you do that over the phone with a customer? Say where you want to do
Like what I do with the customer itself, I like to do the data sheet saying, oh, this is what this is what I need calibrated, and these are the scales. These are parameters that I'm dealing with, and I can go in and just add all that.
And really, that is some effort, but that's kind of a one-time thing, because
Right.
after you did it the first time,
Right.
the next time you just go and it's all there.
Yes.
Are you entering one at a time, or are you doing import?
Well, I'm not entering one at a time. I'm importing them from my laptop itself.
Okay. Do we have create tags yet on eMobile?
Yes.
Is it just for Logic now?
It's just for Logic. So there's been an upgrade where you can actually, if you get out to the site, you could add a new tag to the Beamex.
Right from the app.
Okay.
And then it'll create it as a new tag in the database. So we only have one customer, but just for your information, we're not going to spend a lot of time on this, but I've logged in to logical.beamex.com. And if you're interested in this, you can go to this website and create a trial account, and you can play around with it with your MC6. When I log in, I'm logging into my Acme chemical plant, but it's not the same as my CMX Acme chemical, but I created, so you would have, it says EMC here when you log in.
Yes.
Right. But anybody in your company that has a login, you're sharing the database, and there's no software on your computer. You just have your browser. I'm on Chrome right now.
No limit to how many users you can have.
So I'm not a very good manager. I got 104 calibrations to do. We're actually going to enhance the dashboard over time and have some KPIs, show performance. We'll have like a history dashboard, things like that. And we just had a release end of September. So I think we're going to have one here in November. So you can see, we're updating the software and trying to bring new functionality and things like that.
So one comment on that. The goal is to have Logical, the browser-based, be just as powerful as CMX. And you're seeing continual upgrades in capabilities. That's the idea. And it's not just for smaller companies. We have a customer in Europe that does 10,000 calibrations a month in Logical. So it works with all sizes.
And we're talking to a chemical plant that's wanting to upgrade their calibration program. They have some 20 plants, but they want a cloud-based, out-of-the-box solution. The IT people do not want to have to maintain a server, all that stuff. So companies are going, like Chuck said, this is where things are heading. And it does take a big burden off the IT people. If I click here, I can look at history, or I can schedule work here. I'm going to skip that. But if I go to the instruments thing, we have some educational stuff that pops up. But I think, James, you have like customers listed here.
Yes.
So James has every customer, every site that he might go to that they're providing service for. And then this might be a chemical plant where we have a pre-treatment area, separators, we have a common areas, I have a beverage plant, I have a power plant. If I go into the power plant, I can have, tank farm, unit 1, unit 2, scrubbers, whatever's there at the plant. So you can create whatever hierarchy you want. I'm going to go up here to the search bar and just show you one record. So I'm going to call up TT17. And so I typed in TT175 and it found 2 records. So I have the actual transmitter I calibrate, but I can also maybe do the DCS loop or a loop check on that transmitter. So I've got both in here, but let's call up sort of the traditional guy. And I double clicked on it and we just have a long screen of fields. So this is how you can set it up. So there's your tag ID, a description, NASA loft. That's interesting. So our whole sales team has access to this. I've lost control. So one of our salesmen must be in Houston or something. This is a Rosemont 248 with serial number, blah, blah, blah. It's in my bag, I won't get it out. The range is 0 to 500 degrees for 100 ohm platinum RTD with a 4 to 20 output. If this was flow, you could have square root here. Here's the error limits. It's set up for 2% of span. And then here's the procedure. We're supposed to calibrate every 12 months. And we do a 9-point up-down test. So there's all the test points up to 500 and then back down. And then you can have notes. So I don't know how many fields are there, maybe 40, 50 fields, something like that. So that's how you build this record, and now you can push it to a calibrator or push it to your mobile app. It's very, very simple. If there's any questions, shout them out. And then if we go to results, so I've got 2 calibrations on this one. So let's look at this one that was done last month. This actually wasn't done by me. Who did this? Let's say. So this was done with an MC6 because we're showing 4 decimals on milliamps. So the calibrator was simulating these exact values. And it's got A and B for the reference. So somewhere, there it is. So this MC6 serial number was used for the input, and the same serial number was measured in milliamps.
Calibrated
Ed
by
Schuler did this.
Ed Schuler.
There we go. And he did not enter in ambient conditions. So there's the results on the screen. It's pretty much perfect. It's off a hair. Oh, 0.1% off. And then if I want to generate the certificate, let's see what happens here. I can print. And it's creating a PDF file that shows the date of the calibration, and it's our cert number 148. So this is the 148th calibration done in 2024. And I always put these in my desktop folder. Watch it. So I'll file it here, and I have all these other certificates.
Oof. Everything Ned does is proper and it's exact. All the examples he types in are real. I can't do any of that.
And here's the certificate down. So this came from the cloud down to my laptop. So we put our own logo in here. So we put the EMC logo. Your EMC logo shows up here. I think you're doing something similar on the ID. It probably says EMC. Yeah. And so it's got the database information, but it shows that Ed Schuler did this, and here's the calibrator that was used, and there's the number. So all this is automatic to generate this piece of paper. So then EMC, you guys just email this to the client
Yes.
with your invoice. And there is a place to sign the piece of paper. So in practice, kind of what Chuck said in his presentation, that the function with LogicCal and CMX is the same. It accomplishes the same thing. It's just a different tool. So we're running out of time. We got 7 minutes.
You got it, Ned.
Any questions about LogicCal? I mean, if during this break, this lunch break, if you guys want to take a look at it, let me know. I don't know who really would be interested in it other than maybe you guys, but you know, we certainly can do a demo over the web or something. Yes, sir.
For the search function, do you have any kind of filters?
Oh, yeah.
Okay.
We also have a managed work feature I'm not showing you, but you can assign work to people. So when you log in as a technician, you don't even do any searching. You just say sync up. And if you've got data on your calibrator, it goes up. It pulls new assigned data down to your device. So there's, we're trying to automate that. So you kind of should have a planner driving the software, or if you're working solo, you come up with your own methods to make it flow. But yeah, you can search by date, you can search by model. It's got all that stuff in there. We have a huge library of makes and models. Like we got every Rosemont transmitter in our library. If something's missing, you just add it to our database. You can add this one makes and models to the big list. So it's pretty good.
Any other questions? Let's break.
Wait.
Wait.
Sorry.
Wait.
Sorry to say
I
I'm
didn't want to
guys.
show. I didn't want to show the CMX dashboard.
Oh.
Oh, holy.
Guess what?
We have 5 minutes.
Yeah, you have 5 minutes.
Got 5 minutes. So you already kind of saw CMX, and I think you guys are familiar with it. Again, if you have some questions or issues, I mean, these guys call me all the time. So we seem to fix things every time, but we can do more on CMX. But the one thing I wanted to show is over here on Edge. This is our dashboard, and this is using a tool called Power BI. It's a Microsoft application. So Power BI is just going into the CMX database and pulling data out. I know it's a little fuzzy here, but this is a chemical plant that's been using our product since 2015. And it stopped in 2022. You can't quite see it. But you can see in 2015 and 2016, this is how many calibrations they were doing. And here in 2021, they were up getting close to the 500 mark per month. So there's this is lots and lots of data. The most interesting pie chart here is only 0.6 out of 16,000 calibrations. So 600 out of 16,000 had failures. So it's less than 10%. And I've always said that. How often do you trim? How often does something fail? It's a low number. And this is true data here. They are late a lot of the time. And what's interesting about this database is that a third of their stuff, or 25% or so, is temperature, and then pressure is the yellow, but this is values. And these guys are calibrating their personal protection gas detectors like 2 or 3 times a week. So it's part of their safety culture. So they're using our system to document those calibrations. So that was kind of different. So this is the login screen. But you can, let's say you're the plant manager, you could have this on your phone. You could look at this anytime you want. Instead of calling the shop or the control people, you've got this data. So you can scroll the time window. These are tag numbers. These are the process areas of the plant. So if, let's say you're the operator over one part of the plant, you could look at just the instruments in your area. And if you're Control Southern, you could look at, you'd have every plant listed here. You could drill down and look at just what you're responsible for. So here's that pass versus fail. It's actually 4% of their instrumentation fails. And then here's PTs, TTs, and here's that XXC instrument type that is the
Personal protection.
gas detectors. Let's see, this is the planner screen, and this is a little slow, but let's pick a year. Let's try 2021, maybe November. So this is going all the way back. This is showing what calibrations were due when they first started. This isn't showing much.
Try 22 then.
22 was good. There we go.
It's a heat map.
So this is kind of a, so this is when the activity was real heavy with this. So, so here's November, let's say it's November 24. You kind of have a snapshot of how many calibrations you need to be scheduling that month. You know, how many people are you going to have to pull in? And here's stuff due on the weekends. You're going to pull those in early. So, so again, you could be looking, if you got an outage in a certain part of the plant, you could be clicking on that area of the plant and so on. So the cool thing is this does not take up a CMX license. This does not, anybody can read this. And then this graph is horrible. So when I saw this, I'm like, what the heck? So remember we had those function abbreviations? So if I go up here and click on PT, here's PT. Well, that's pretty noisy. But I could zoom in on a year. But look, they were having a lot of bad failures. But here lately, they've kind of gotten a handle on what they're doing. And the only excursions they had were here, here, and here. So if I'm the high-level manager, I just want to know what happened here, here, and here. I don't care about all that. That's okay. You know? And if I click on TTs, it's even better. So they don't have particular temperature problems. And these are probably just bad entries, like somebody fat fingered something, right? But what was that? So the last thing I'll show you is the gas detectors. So when they first started out, they weren't using the gas detectors. They weren't using this application for gas detectors. And then somebody said, we're going to start putting them in here. They got a problem. They're chasing their tail. It's coming in high, so they're adjusting it. They think back to zero. They go out the next time and it's coming in low. They turn it back to zero. It's coming in high. So either their tolerance is too tight, it's not realistic, or they're just over adjusting. They're constantly adjusting these sensors. So, and to me, this is a real important device. If it doesn't go off, you could be dead. So anyway, this just fell out. This information just kind of fell out by looking at it through this new dashboard. So this will work with SAP. We have a calibrator icon that shows you when your calibrators are due, so you can be planning when to send off your standards, and it's not just the Beamex calibrators. And then we have some advanced analysis. So I just wanted to show the dashboard, and you guys that have had this for some time, this is the kind of information that will just come out. So we've sold this to some longtime customers, and it's really eye-opening. And to me, what I like about it is it opens it up to everybody at your facility. It's not this private thing that the shop has. And do you guys need it? Probably not. You don't care. You just want everything to be perfect when you invoice the customer. But we're going to add some of this kind of stuff to Logical as well. All right, I'm done. Any questions? So how long's the break?
Well, we are going to go to lunch in just a few minutes, but before we do, a lot of you had the opportunity to see our beautiful new office upstairs, but that's only half of it. So I'd like to introduce Mr. Orlando Molina. He's our quality and service manager, and he's going to show off his new portion of the office, which is our new calibration lab. So I'm going to let Orlando say a couple words about the lab, and then I'd like this side of the room to do the first tour. We'll let you guys eat. I promise they'll save you stuff. And then after they're done about 1 o'clock, we'll have you guys go tour our new lab. So Orlando?
Yeah. Well, first of all, welcome to.
No, what's
Yeah.
15 minutes using reclaimed wood and parts. And I'm gonna hang my webcam off of this clamp that you see. Here's my rinsing station. We've got water to wash off, and I've got a water dip here. And then we have different pH fluid as well. And you notice somehow I got into the authorized area and nobody knows I'm in here. So the different fluid, I've got one of them. And so back again, my assistant thought it would be funny if the fluid was out on the desk and I didn't know what was what. Apparently nothing is labeled here. So I need to pick out the proper one. So scientifically, there's a way to do this. If you didn't know which was which, or what was your pH buffer solution, what would you do? How could you know? We've got a couple, whoa. You know, this one could be a couple different things, and I'm not sure. Okay, luckily that was an energy drink. That one's okay. This is some kind of sports drink. I don't know. This one. Okay, I don't think that's it, but all right, that tastes like flat beer. That can't be right. And so we've got the final two. Okay, that's it. This is my pH 10, the missing one. I'm gonna put that over here. Okay. Ned is a good example. I'm a good example of a bad example. Don't ever do what I do. But how would you end up taking your pH buffer solution? You know what? Yours is probably labeled. You know what? That's probably it. Next, we're gonna do pressure. What was on first? We have a couple options. We have a manual pressure pump. We have this thing. This is actually new. This is the first one in North America, by the way. It goes to plus or minus 160 inches of water. What is that? 5.5 psi?
Yeah, 6.
Okay, 6. We have an EPG that does vacuum to 300 psi. We'll show that shortly. And this is a Clock 8 that does low. What is the lowest? 125? There's an option to do low inches of water.
Yeah, we have 150 and that one, 3,000 model.
And up to 3,000 psi. So this will automate a pressure calibration, but you need a pressure source. So oftentimes a nitrogen bottle is required. But we do have your note recorded, a high pressure automatic portable pump. Was that it? Does that capture what you guys are wanting?
Yes.
Okay, or a couple of you. Oh, pressure workshop. Right. You know what? Let's do this one. I have never seen this transmitter until yesterday. So this is Ned's. This is a Siemens, and it's a 420 out. 0 to 96 inches of water. Why didn't you make it 100?
Square root.
Oh. And yours is this one. Oh, so you can probably see this. You wonder why Beamex is green, I suppose. It says it runs on kryptonite. So it glows a little bit. There's no radiation to be worried about, though. So right now, the pump needs to be connected through USB. Set it up. Are they looking at some leaks? They're right by. Okay. Do you mind pointing that guy? Have you guys heard about the vent valve?
No.
We've been asking for this for over a decade, and R&D has given us this. Shows up like this. You connect it to your Beamex hose. This gives you a vent point with pressure, with physics. Wherever you vent, that creates a low pressure area, and everything runs to the low pressure. So everything, all your crap in the line ends up coming out wherever you vent it. So if you're using a pump and you vent it here, all your crap runs through the hose into your pump, and now it's all in here. So the vent valve gives you a specific spot to put it, and it does come with a hose, so you can direct the outflow into a bucket or somewhere that you want. It's also just a convenient way to vent it.
Does that vent work for the high pressure as well?
No. Any other questions I can't answer? Okay. Yeah, sorry about that. But there is a dirt trap that does work for the low pressure and the high pressure. It will help with particulates. Thank you. Dirt and moisture trap. Documenting Cal. I'm assuming everybody here has seen one of these guys. F101. I think this might be it. It probably is mine. So, you may or may not have seen the before calibration notes, but here's where you put in a safety message for your people. Ned would put in something appropriate, like make sure to rinse off your pH probe or something before the test. Okay, pressure 0 to 96 in, 4 to 20 out. We are providing blue power. I do want to show you one thing. If I go to the blue gears, that's the setup information, and down here at the bottom it says automatic control. And if you have an EPG set up, this is where you select that you want it to do the pressure. And if you don't, you can just click on it and stop it. Fine. Actually, I'm not going to ask that. Never mind.
It's also got square root.
Thank you. Forgot we had that on. So, we normally vent it and hit the 0 button to zero our pressure module. Well, I'm going to close the vent at the first point. Okay, here's where we have a loose connections. Oh, so yeah, I put this one on, and this was not intentional. I'm so used to barely putting these on with that O-ring that sometimes I get a little too loose.
Move your mouse. It's trying to get to 48 inches where it expects this odd milling amp. Now it's going to 72 inches. So those are just the target numbers, but you can see it's off. It's reading high.
My transmitter is not off, it's just different. Let's go like that. Yeah, it's even more colorful. Oh,
Yes, I had to jump.
I'm not actually happy that jumped in. I wanted failure. So when you get an S-bound that fails, what do? Do you look both ways?
Delete it.
That's one option.
Copper red wire. Copper red wire.
Yeah. You know what? Yeah.
I don't want it to fail.
And you know what? We run into guys that do that. They will actually hit cancel and abort and see if anyone's looking, and then they'll go and adjust it, and then do the test again with a brand new as found that's passing. If you do that, you don't get any trending information of if it's going up or down. So as ugly as it is, you need it. So, calibrated by Ned. Is there, wow, that's okay, I'm not gonna do any of that. Ned would. Now, we did have another test on here, so I'll deselect this. I don't want it to combine with another one. I'll do an as found because I want to adjust that. Do I have to? Well, technically no, but it depends on your SOP. If it's 70% or greater of your error tolerance, that might be your limit of when to adjust. That's a pretty
So
common.
Jeff, would you adjust that?
Yeah.
With your procedures?
Well, legally, it would be okay to leave it, but me being the person I am would adjust it.
Right.
It's a matter of who's doing it.
Yeah. I mean, Georgia Power Southern Company has an interesting approach. I like it. If it passes, don't adjust it. Don't adjust it to things. That's their guideline. But that one was so close.
Right on the line, yeah, we went ahead and do it.
And that is my personal SOP as well. If it passes, leave it. I have to admit that. But, okay, I need my Trex. I need to talk hard. Bring me my Trex.
Reese has Pro Console. You can use his.
It's in the car.
Yeah.
All right, fine, it's in the car. Or I could hit the secret button up here at the top left and start communicator. I think I might need to re-zero that. He's hanging down. Okay. So yesterday was the first time I saw this. So yeah, we are getting minus. I just vented it. I was curious.
What if you hit the menu right now?
Oh, you know what? I just opened that.
No.
So Ned's
Actually,
right. In some cases, under this
Can I say
policy,
something? Can you click on the house button and go to show? I'm just wanna see if just you explain this because sometimes you just have measure variables there. So when you're going to trim, you don't see the online. And maybe someone can get like, oh, what happened here? How can I trim this? So I just want if you can tell the guys that if you select that, it will just show you all the variables that you can actually measure. So don't get like scared if you try to trim it and you just see those green sections. It just matters to go back to your house button and just select all, and it will show the online one that you can go through the adjustment.
I'm glad you mentioned that because the calibrator remembers the last way that you had it. So if you're using it on show measurable variables, someone else grabs it, they go to Mark Communicator and they're seeing this, and they're expecting online and all the other options. You just need to come up here and do show all. When I do it, my zero was on, but now it's down a little bit. I'm guessing I would just need to re-zero my transducer.
Well, you can do a 0 and vent it. So that's a true 0.
Based off that initial graph, I was just going to run an upper. What do you want me to do?
I would just do it. So just to save time.
You should be over here driving this.
So, Antonio, do you always trim the 0, or do you always do the lower trim or the upper trim? What is your...
Most of the time, I just trim 0, first of all.
Exactly.
Because that fixed 98% of the problems, to me, my
In fact,
experience.
you wouldn't even have seen that kind of graph. You'd have seen a zero offset.
I don't even, when I'm gonna do zero, I don't even have either channel 1 or channel 2.
Yeah.
I just go straight like bang, 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 bang.
Zero,
zero, zero, zero, zero, okay, you know, move on, because that's fixed most of my problems.
More than 9 times out of 10.
Definitely.
Almost all the time.
Let me back up a second. So this is Ned's favorite way of doing this. This is the first page, and if I do click on one here, no, I did it backwards. Up here under that button he was talking about, the secret button, enter set value. 96, check. So now we'll take this up to our upper range, we'll let it stabilize a little bit, and then do an upper trim. And even if we don't get exactly to 96, if it's 95.0, you can still tell the transmitter that it's 95, and it'll accommodate that.
I'm not gonna say that because they do, they like it. So that'll be nice.
Probably am,
That slowed down much better.
okay, now we're bouncing.
I'm gonna say, man, it would be nice if the graphs is showing there. That would be great. Give you a better idea of doing that.
Red check. It tells you what it's going to do before it does it. Apply high pressure, we did, but I'm not at 96, but I'm telling you, don't be concerned. Press OK when pressure is stable. And I'm not concerned because of this. I would click on the copy paste on number 1, that copies window 1, pastes it up here. I'm telling you, it is 94.842, so it should trim the output to match that actual pressure. So watch the bottom right. This is a fast processor.
Siemens, that's why they did.
I'm not used to it being that fast. Okay. So I hit the X to bottom out of the heart communicator so that I can just see where I'm at. It tells you to vent at the end, but I never do because I want to see where I'm at. And I can tell that I'm good, so I don't have to worry about it. I could vent or I can just hit start. What do you tend to do?
I would hit the set value and I'd set 0.
Yeah, okay.
Then if you do want to, let's see how. So see, you just had some offset pressure. That's pretty close to 0. So you could vent and zero the calibrator again if you want to, but I think that's pretty close.
Based on the values that we got in communicator, I was thinking it would be. And all right, I'm gonna start. I know on some transmitters that first ball is going to be jumping up and down, and I'm actually surprised with the Siemens that it doesn't do it, but it's clamped. Get a good number on 0. You can't take the square root of 0, so if you take the input up to 1% of your span, that would give you a good number as a first test. Is that fair?
Yep.
I don't know. I don't think you did a very good job.
All right, should we adjust it again?
Yeah.
Would you trim
Yeah, let's
this?
start.
See, if I handed that in, they wouldn't even believe it. So, okay. I'm not going to put a note in or anything else, but you know what my favorite part of this is that these are all the numbers that you don't have to write down. I love that. So I'll save it. We'll save this as left, it'll combine it with that previous as found and hit, so we're done. I'm gonna hit back. I could hit the, was this you too? Okay, now I'm saying, why didn't you cut the red wire?
You were advised that. You had 2 chances.
So with this, I think you should do,
Who's next? You want to do the PGL or pocket? Or we do the switch?
how many of you calibrate switches? Are you seeing the same number or are you seeing fewer switches year over year? What's that?
Ours going down, replacing the transmitter slowly but surely.
Okay. That's what I was wondering. All right, let's do the switch. Switch.
PS45C. Can you find it? This is a real expensive switch.
That's so dripping sarcasm there. The switch itself is out of my microwave.
You used to sell these, right? With it.
We literally swapped that switch out yesterday.
Now, where am I supposed to connect?
Hey.
So I gotta move to my high pressure port. Then my test leads, I gotta move those. Okay, so the range of this switch is 0 to 150. You can put a set point anywhere, but this one is supposed to trip at 45 and reset at 30. So I'm just going to hit the green check. And the switch is open. So let's see what happens. So I think in the settings, I told it to go to 25. I kind of framed it up. I said, go to 25 and start ramping. So it takes a little while to get up to the 45. But the EPG has a series of chambers. So we're we're pumping into the first chamber, but then we're venting into the next chambers. I think there's 3 chambers. So we're kind of getting a ramp out of it. And now it's on the graph. My tolerance is pretty loose, 3 PSI. I see the 6. So it tripped right there. Close enough. And there's no guard band on the reset of 30, but we still make you document where it resets. And then the guys at Papeland have switches that can chatter and give a false actuation.
Yes, makes contact.
So this is now on the graph trying to get to 30. And it's going to stay green because it's not going to fail this switch on where it resets. It just documents it. So if you have a lot of switches that are repeatable, they act sort of the same way, this can work really well. So it just reset at 29.2. I do have to accept these two readings.
Because he's in manual mode.
And so I just put those to memory, but I told him to do 2 cycles. So I'm gonna make you watch it again. Does anybody do switch testing where they do more than 1 cycle for repeatability? Yes, sir.
How often does it capture, the switch set point? How fast is it?
The calibrator has about a 250 millisecond response time. So it's not ultra fast.
Right.
But it's almost like you have a chatter issue. It's almost like you wanted to wait till it really flames or actuates. It's almost like we need to slow that down somehow. But I think with this system, we help you test a switch better than any other system you might use, and it helps you frame it up the way you want. The only problem, I would say, is if your switches aren't consistent like this, then it's kind of hard to, frame up this kind of information where it's 45 and 30. Have you done much of this, James? No.
Ned, will you show me where you turned it off where it passes even if you fail the reset point?
Yeah.
Because mine
There's a
always show up
setting,
as-
yeah, there's a setting in CMX and on the calendar. We'll go through it.
I haven't found that magic button yet. Mine always fails the reset. I don't know the reset.
So this one captured those 2 numbers, and I'm going to put those to memory. And I did 2 cycles and said it passed. So I can go through and make a note and so on, but I'll hit save, and I'll save as both. Boom, done. So Roy, if you would, maybe you drive it, hit the gears. So how many pages are there? There's 11 pages, a lot of pages.
So, does anyone else run all pages, 11? Basic starts out at 6, it could be 7 or 8. I tend to do basic.
So the output is a switch.
But one thing I'd like to say on trigger level is dry contact. If it's a resistance-based switch, dry contact is the only answer here. Otherwise, it will never detect a state change. Wet contact is voltage applied or a voltage switch. Set point, reset point. This scan range, is this what you were referring to?
Yeah, this is kind of where to start the pressure ramp and where to quit. You could even set it higher than 50.
You know, that step delay and final ramp delay, if I load something from CMX, it's pre-populated with values. If I create on the MC6 by itself, it shows zeros, and it seems
There's one guy that knows how this works in the factory. And the guy that designed it is passed away. So I don't know of many customers using it, but it hunts for the set point.
Or the pre-scanning.
Yeah.
So, yeah, pre-scanning is if you don't know where the set and the reset point is and you want it to just go find it. It will take a while. And I did that on a temperature switch once, controlling a drive lock, and it took 2 hours. And I didn't realize that. So make sure you have that off on standard tests. So the reset point not calculated. That's the no guard band on the reset point. And as a technician, This is the part of the switch test that will save you brain damage. Because you care where a switch trips. Now I'm talking about a non-critical thing here. You care where it trips, but you don't care where it resets, as long as it resets. Like a lube oil switch or something. So reset point, if you choose plus minus, that means it could be a rising or a falling, but you have to declare what the error allowed is. And if you don't know what that is, then choose not calculating. I mean, if you don't care where it resets. It'll still record the reset, but it won't fail based on that. What else?
You can also, if you were to pick plus or minus, on the next screen, there's a field. You can make the window bigger on the reset. So we've got it that it needs to trip within 3, but we could use a multiplier of 2, and on the reset, that means as long as it trips within 6, it'll pass. So you can expand it if you want to approach it that way.
Do those terminologies, does that show up the same way in CMX?
No.
I want to set it up in CMX, because that's what I've been doing, not out in the field.
Beamex, it shows up as none for the reset calculation. The choice is none, not
Yeah,
calculated.
the fields are in there, but they're named different.
But there is a reset multiplier field. And the directions aren't upside down. It's a plus minus thing like you're used to. All right, why would I fix that?
Okay, I'm just going to cancel over here. Do not want to save changes.
So that's a pressure switch.
What did you have on the for the pot?
Do we have PT400C on the list?
PT400.
Where's PT?
Can we go back?
Let's see it.
Hey, real quick, you guys are connected Bluetooth?
Net one. Net.
Yeah, you guys connected Bluetooth right now?
No.
No.
What part? How are you connected? No, I'm talking about the Beamex and your laptop.
Oh,
MC6.
USB cable.
Oh,
you got a really long cable
That's what I thought, yeah.
Oh, okay.
going around to the laptop.
What is this? This software, I guess, on here, that how you're controlling?
Oh, so this is the program.
CMX program.
This actually is free. It comes with CMX, and you can even download it from our website if you want it.
Oh, just showing the calibrator like this?
Yeah, yeah.
So it's called a remote.
No, this
control.
costs $1,000 payable to Edward Espy.
You know what? Email me. It's free.
Yeah.
You want to show it?
Okay.
We sure can. So the one question we get oftentimes is this a calibrator emulator? And it's not. We're just literally controlling the calibrator. And I think, Ned, you were the one telling me the story of how this came about, that somebody was using this in R&D and the...
Yeah, sales guy somehow walked past the R&D engineer's desk and he had this screen going. He was like, "What's that?" He goes, "This is how we test stuff in the lab, you know." Well, I could use that for demo. So anyway, this is our demo.
It is the best tool for demoing and training. And even if you guys are having trouble on something and you call and we do a Teams meeting, you can share your screen and you can see your calibrator live.
I'll call that PT400 Roy and we'll calibrate. We'll have to.
It has to be connected to their CMX.
Do you want me to copy it and rename it?
Let's edit it.
Okay. And you all know you can copy these from the calibrator. Just rename them if you want. Instrument input change.
We just want to add the POC 8, but we need to have it connected up.
Yeah, right.
So I'm going to disconnect the EPG and plug in the POC 8.
All right, so across the top, it says controller number 2, pocket. I do want to go from the main menu into settings. Controller come on. I need mouse training. Sorry, guys. Controller presets is where your information is on everything you control, whether it's that pocket, it's EPG. This is what I wanted to show you. Control mode, shut off or continuous. Shut off means once it hits that 50 PSI threshold, it stops. And if you have a slow leak, it's just gonna sit there and go down. Continuous means it'll keep feeding it to try to keep wherever you're supposed to be. And we have the best luck with continuous. The first one here is red, that means it's disconnected. We are disconnected from that EPG. If I go down to the next one, this one is set up for the POC 8 and it's not red. And it's on, I did not even click that. So this is on shut off too. Actually, do we want this one on shut off?
Yeah, it's okay.
We're on a little compressor and
So this is PT400. It's a WICA transmitter. So this is our swage lock adapter. We have a quick connect. So I can just hand tighten to this transmitter. And then I'm getting on the terminals on the back. So I've got a hose to the calibrator, a hose to the back of this guy, and Milliken has this controller, it goes to 3,000 PSI, but you guys could do what I'm doing right now with your controller, even though it goes to 3,000, you can control the 400 inches of water. And I'm just pulling in an MC6 pressure port that gives you the good accuracy at 400 inches of water. So this is not accurate to measure 400 since it's how many inches is 3,000 PSI?
I don't know.
I don't know.
A lot.
27.7 times 3,000.
Yeah.
So, yeah. So, so this should work the same way as the EPG if you set it up right.
it's 90,000. So you're saying it should work if I click the button as long as I set it up right.
So you can vent it.
So
it's venting on its own.
Okay, do you want me to do this anyway or just leave it? You know what?
It's pretty
check our hookup. We're not getting millions.
Oh, because we're on the switch.
So I do this all the time. If I'm doing transmitters, I need to be on loop and I do a switch and I forget to change those 2 wires. I hope someone else does this besides just me. Thank you. All right. Start.
So one other thing, I've got a Pep Boys compressor for doing your tires behind this guy. So this is not generating pressure like that does. You got to have a source behind it. And National Grid uses this thing from Eaton Instruments that has a tank inside the case. It's a pretty big case, but they can fill it up to 3,000 and it fits in their truck. And they'll put that, something like that behind it. So and it does require AC.
I just did a manual vent again and hit a 0. I'm going to start.
Yeah.
We're in automatic mode, 5-second delay.
So tell them about when you do 1,000 or more PSI, this thing's really nice. I love it. It's real safe. it's just as fast delivering.
Now, when I did first hook it up, everything up to the pile out, I did go outside, peek through the window.
Like this?
Yeah.
Sounds like you know from experience.
Also notice that we're not hitting exact numbers, but this guy's actually closer than this guy at set points. And, but we're doing an exact calculation of this versus this, right here. So this is a nice tool if you have a workshop environment.
Wait, I just hit pause. Son of a. I just want to make sure everyone has seen this. At any point here, before you get to the save or completed, you can hit pause and you can undo points. You can undo all the way back to the beginning if you want to.
Also, look, this is a good thing to show. See how we got this real slow week. 74, 73. But look at the milliamps. They're dropping too. But, with this system, as long as this isn't bouncing real crazy, you're making a really good measurement. Since they're both dropping kind of together, it's a very accurate calculation. So it's a nice system. So you can play.
Before I hit play, great, it's just 7 seconds. We had a 5-second delay. And if that didn't happen to be enough, maybe my transmitter had a bunch of damping that I wasn't expecting. I'll hit pause instead of going back to make more delay in between each step. I'll just hit pause to make sure it settles and I have enough stability. Okay, it's done. What's this? Beer flow? You know what? You need to be more professional, and your serial number is SB Special.
Because I can chug a beer faster.
So, Tiffany, could you bring up HR for us?
You guys actually recording.
Great. How'd you save this bill?
Yes.
You already.
My
Roy,
son's wedding, they were holding everybody.
you show how to do undo before finish your test, but you're still able to undo the last point. Even when you finish your test, when you are in the last point. So I just tell him like you're still able to undo that last point.
How? Yeah.
You can do it up there.
You're gonna make me do another one?
Yes.
So he's saying that we can get to the last point and still undo when,
Once you say it passes, you can still
Yeah,
go
you
back.
can still go back and undo
Before you
the
hit
last-
save.
the last point. Yeah.
If you don't hit
Yeah, you'll
save,
see.
you only don't hit save.
Exactly.
all right. I learn something every time.
No, I think you should keep saving and just redo it.
Well, literally, if I do a training or anything, I learn something new, especially from you guys, because there's a huge amount of knowledge.
But this is an expensive option. But it's really versatile because you can, use lower pressure ranges to achieve an accurate measurement. And just let this do the work. And you can see it does a really good job. So that, the only downside of this is it's big AC power and it requires something behind it. So for those of you that have a shop environment, it's just I like selling this as a solution. It's a nice solution.
Just does, I'm not gonna name names, but does Chad still use that on a dolly?
Yeah, I think he's got 3 of them.
And you just won't say any last names, how's that? Okay,
Over there.
this is the part where I just said you cannot undo.
Go to the home button.
Yeah.
What?
With the home button. And undo.
Son of a. All right, you Call security. All right, that's pretty cool. When did they add that?
It's been there forever.
Oh, thanks. All right, thank you, Antonio. Bonus points. So yeah, if you get enough bonus points, somebody asked me to bring some, well, I'm from Colorado. So if I could, bring some pot from Colorado and, so I said, sure. And, you know how hard that is to get to the airport? Do you have any idea? So I do have, I brought a little pot from Colorado. So Antonio, this is your prize. You have the most bonus points so far. What's in it? All right, it's right here. I'm not answering any questions. Oh, so, all right, it does make me hit play. So after I did that undue point, it is in a paused state.
What I like about undo is don't ever forget you are in charge. You're not a slave to this. You make this work for you and make it friendly. Don't overthink it or make it. I've had some engineers design real complex test routines, and you're like, just do a 3-point up test. You don't need to do up, down, blah, blah, blah. But yeah, you can get killed by all this. So make sure you use common sense.
Final note, before I save this, I think I did save this both. On the previous one, I had no intention of doing another test, but I did. And maybe there was a good reason for it. But I would still come in here and do save as left. You can have as many as lefts as you want. We're going to use the last one to give you a final stats. So you don't have to worry about deleting or keeping track. But if I save this, I now have an as found as left, and then I have an as left. How do I view that from here? Or can I?
Yeah, you can. So you go to, you gotta go back. And then you go to where your records are, your findings,
All right, magnifying glass.
and then you go up to, the home button. And there should be, I can't see the results history, yeah. And then you have two, so you can delete the middle one, which is the.
Let's say exactly right. All right, you get some of Antonio's bonus points. You get half of that pot. Split the pot. So it is possible to delete like that middle one. You could do that, and it's definitely not necessary.
Well, it is if you want to print, because then you'll have two sheets.
Yeah.
An as found, as left, and then an as left, so print a second sheet.
I'm just doing a date and timestamp check to make sure it is that middle one. So if I select that, now if I go to the secret button, then I can do manage, delete this result. Yeah. All right. Now I'll do results history. We should just have those two. So honestly, if this were me, I would have deleted it too, even though it's not necessary. But anything else here?
No, just to recap, we've demoed the portable battery powered pump, and we also did a switch test with it, and then we've done this high pressure capability. It's more of a shop guide. How are we doing on time? 10 more minutes. So the last thing we wanted to do, Roy, was this guy. Has anybody used this pump? Does anybody have like super low inches of water like that? You want to control a 1/4 inch of water or 2 inches of water, or something really low?
Yeah.
So this is our answer for really low pressure. You know, we also have this pump, this goes to 500 PSI, really almost 600. It also, by pushing this button, you can get a vacuum out of this. So you can control low inches of water by just turning this little knob. But I think when you get really low, like 2 inches, it becomes difficult. I will say, like, you can control inches of water to 2 decimal places with this. With this pump, you can control 3 decimal places of inches of water. And the range on this is plus or minus 6 PSI, which is about 160 inches. And you just turn this wheel in the back, and there's a little plunger going in and out of this chamber. The actual chamber is kind of hard to see, but it's maybe a 1-inch diameter. So we have insulation like styrofoam around the outside. So we're trying to minimize temperature effects. So when you use this, you really should put your hand on here. Even the temperature of your hand can make the pressure run. And then this serves as a vent and a fine adjust. And this is where you can get the hundredths of inch of water control. So do we want to rearrange this guy? Or
Sure.
Okay.
Your time.
You have any heated compression when when you raise the pressure? You have
Not
to
so,
wait
it's,
for it to come
it
out.
will, but it will. So, but if you're doing 2 inches, you're starting off at 0, so there's not a lot of effect there. So you should be able to get to it.
For that reason, I use the pause button on that one anyway. For that reason, I'll like occasionally pause to kind of let it equilibrate.
Okay, yeah. I would agree with that. How much do you want?
I'll ask the audience. You want to see a 1/4 inch, or that might be too much? Maybe 2 inches? You can either do plus or minus 2, or just 0.
I was gonna say 5, but okay.
So what's going to happen
I don't want to hit that.
when you get so low?
That's the question.
Well, Siemens will tell you 100-to-1, right? But that's BS.
Yeah, what's the turn down on the transmitter? How low can you go?
10-to-1 is without a doubt okay. So we could go to 10 inches easy. So I think we're okay. The problem, though, is that we got the low side vented. So just the HVAC is going to make the low side flood.
I was trying to calibrate the one outside one time, 0 to 6 inches, and the wind was making the output go up and down.
So-
Close it. to get it closed.
So we do make a sensor that has 2 prongs coming out. So we can do a true high-low differential. We make one that goes 4 inches. You guys, I think, have one somewhere. But it's plus or minus 4 inches. And you can get it in here as well.
I'll be very careful.
You go to 400 MC.
No, I just made a new one. You have a 2? Ah.
So we're also picking our 160 inches of water range. So we're pushing technology here, but Beamex module is good to about 10% of its range, so we're real accurate to 16 inches. I think in practice we're really good at 8 inches, half of that. So we're kind of getting into where our pressure module is not accurate for 2 inches.
Oh, right. Anyway,
Huh?
So, I did not change it from square root. This is gonna be probably the nastiest thing we've ever done.
It's still square root. In here?
I didn't change it, so it must be.
Okay. So here's that jumpiness you were
doing
about.
2/10.
Could you take us up to like midpoint or something just to see if we're, if we need to change it to linear? I think it's still 96. It told me that it took the 0 to 2, but get map values gave you 0 to 96, which is what's the original. So I think that's still the case. And I'm thinking 2 was too small maybe for it to take.
Oh, it didn't like the 2. So go back to hard. You can hit it from here.
Well, how about, I was thinking about just changing this test back to 96 and you just give yourself enough room.
Okay.
I know that's not what you want. But for the sake of time, I think this is the best answer.
So I got the pump fully vented and I'm backing out.
So we're going with the 96 just to get this, to do the test with that. All right, you're up.
Getting a jump to 0. You still have square root on
Yeah.
Yeah. Well, we're back to 96.
Take it 1%.
I did make it 1.
1 would be 0.96.
Oh, 1%.
Yeah. You get a 10% reach.
Thought you were mentioning the.
Or is it straight line until you get there?
It's 5.6.
That's about 10%.
So you should start our test here.
Agreed. Go ahead and hit it. Let's try that. I would definitely expect some odd errors since we changed it. Well, wait a minute.
No, you got square root on, so it's fine.
Yeah, we didn't actually, I don't know, 0
Then-
first would have mattered.
So if I want to get to 24 even. Trying to turn. Wow. So I can kind of get there quick. Two. So I almost look at the black stripe and just try to get in the middle. I don't even look at the numbers.
I don't even see the numbers up there. I just.
Done this beforehand.
Got crap.
So this is why DP flow meters are crap on the low end. They're just not accurate, but they're pretty good with a decent flow. So this transmitter is working pretty good. Yes, ma'am.
I was just like, how much time you have left?
Well, we didn't do as good a demo on this, but, just know that if you got something really low, this is your tool. It's manual. You can get a 5 PSI or so range in here. And you could do automated control on low inches of water with this guy in the shop.
All right, are we? Okay, so yeah, I just got the signal, the middle finger means 1 minute left, or
That means you're number one.
All right, so let's take a break.
Yep, 15 minutes, we'll be back at 2:45.
All right. Okay, we're gonna do a temperature workshop, and I just want y'all to know, here at Reverend Engineering, we take safety seriously. So I've got my safety glasses on here, and my, actually this, I probably shouldn't even talk about this. But I told you about the kryptonite thing, and we have some radiation issues periodically, and so I have my own personal radiation detector. And if this ends up beeping, somebody let me know, because I don't always notice. Actually, could you go to the next slide? We have an MC6T temperature block. It has an MC6 built into it. We have a temperature probe that we're testing. I'm curious of how many of you, if you're testing a temperature probe, do you ever test the loop? Do you test a probe connected to a transmitter in your mess? Both. Yeah. Okay. So who of you end up doing a loop of the probe all the way to the DCS display? So there's that as well. How do you decide whether to take the milliamp output of the loop or to go all the way to the DCS?
Customer.
That's fair.
Customer.
Yeah.
How do you fix, if the probe, let's say the probe's off a quarter degree, how do you correct it?
As long as my transmitter is perfect, that's something else down in the loop, you know. And that's one of my fights with some customers, you know, like they want me to tweak my instrument to satisfy their HMI readings. And I told them, like, well, if I can do that, but my calibration will be voided. I can't provide you a certificate for it. So why you are calibrating instruments if you want me to tweak it to satisfy your readings? You know, some of them say, oh, but this is validated already. Say, yo, I'm validating your instrument right here, the calibration. So he can choose which one you want.
I pray for a quarter, I'm trying to do ±1.
Here's one other scenario I want to ask. And I just had this last week, visiting a customer. I can't get to the probe, and the probe is either good or bad. So if I'm getting something from it, it's good, and I'm just going to check the transmitter. And this is a real question. I don't know how to respond to this. Do you guys have any feedback on that? Is it ever important to test the probe?
Yeah, of course.
Are there cases when it's not?
When it's stuck. You can break it off.
Or,
not safe there.
or where someone installed it before, put the skid here, and now you got a wall here that you can remove the sensor. That's another good reason to test it.
Maybe it's not safe.
Or if it's covered in insulation, and you don't know if the thermal well is screwed in or welded in, and you unscrew the thermal well without knowing you're thinking you're unscrewing the thermal well, or you
Okay, sounds like it's from experience.
Oh, it's better. He got the promotion.
What if you can take the probe out and you don't? Do I say anything then?
If you can't take the probe out, you say?
If you can take it out, but they won't. I think I'm truly asking for opinions on what to say, or is it even important?
It's application dependent.
I mean, most of the calibrations we do are instrument calibration, we read the 4-20, some customers require a loop. And we have to do an assessment beforehand. I mean, if we can't get to the probe, we'll let them know. So you're either gonna have to break it down for us or whatever, and then reconnect it so that we can look at the HMI. But it has to be a pre-assessment kind of thing.
That's fair too. I guess you need to know the criticality of what you're actually testing and what's next. I think we should get to the point of starting that guy. What's the name of the sheet? I don't
If
know.
it's me, I create just two functions.
Oh, who put this in here? What to do with the other short
One
probe?
point.
I'm thinking this was marketing. All right, fine.
Hello, this is Tiffany.
Yes.
So, this is common in food and beverage. You've got sanitary sensors that are shorter and they don't work in a standard insert.
IFM sensors, 2 inches long, 50 millimeters. Then go to the bottom. What?
The 2-inch,
So it's a
they won't go down.
IFM, yeah, it's on 150 millimeters, 50 millimeters. Will a 2-inch or 3-inch, not 2-inch sanitary flame.
So I'm taking this probe out of this dry block because it's right now set to 60 degrees and I'm thinking that's safe. In this scenario, we have a custom drilled insert to this probe and we've got a hole set for this sensor. What's the width of this? 3 millimeters. So with that, now my sensor's in here at the same depth as my sensor and we're able to get a good measurement here. I don't think you can do less than 2 inches or 50 millimeters successfully, or it's not advisable.
Inch and a half.
Inch and a half? Okay.
It's a good idea.
So that's short sensors.
Well, and the problem is the dry block is measuring the temperature down here. So there is a gradient at a shorter depth. So just an accurate measurement.
Is there a separate hole for your reference sensor?
Yes, sir.
Yeah, there are 2 holes.
Is it like a factor of 13 or something of the width? It's like you want 13, the American.
Do we have to add one solution?
What's that?
So do we have to add what the solution is?
Well,
I mean, what's the solution? You guys asking us.
well, we can drill that insert for you. So if you send us a vendor drawing of the short probe, we can send you a drawing to approve, and we'll drill it for you. And then it'll just drop into this. So I just did an insert for Alabama Power. They have some kind of high temperature, it's called a fen wall. I don't know what it does, but it actuates at 700 degrees. So when they're in an outage, I guess they pull this fen wall out of the process and hit it with a blowtorch. And if it actuates, they say it's good, and they put it back in.
Wow.
So we're doing a custom insert where they can run the temperature up to like 700 to 755 and see if it actuates, in the ballpark. So the probe's about the size of my finger, maybe about that long. It's short, but we just got that order. It took a couple of weeks back and forth to get the design. So we can, if you have something weird, let us know. We can come up with something. Nestle at the Hot Pockets plant where they make Hot Pockets, they have short sensors, and we did one that was 1.5 inches. And we came in at like a 45-degree angle, so we could cross in front of the short sensor, so the 1.5 inch sensor was offset, and we're making a good measurement for that. And I was like, how do you guys make this measurement now? The guy's like, we don't. He was real excited.
What temperature was the measurement?
I think it's, it was above 200 degrees Fahrenheit. It wasn't that high. It wasn't the cooking temperature, but they also are monitoring frying temperatures. But they don't have the short sensor field. But after they make the Hot Pockets, they put them in a deep freeze. They take them down to like -80 or something. And then when they put them on the truck, they stay frozen until they get delivered to the next warehouse. They're so cold.
even after you microwave sometimes.
Are they still frozen or
Yeah.
definitely
These
not?
are the-
We have our resident.
Yeah, they're both.
Sometimes they never run through.
Then you overdo it, you get the back.
Oh, yeah, it's like
Have you ever gone to one of those?
oh, hand right.
Yeah.
Hot Pocket plant.
They got a couple. I was training in one of the Hot Pocket sites, and they said some ridiculous number, like they make 1 million of them a day, or it was an obscene number. I don't quote me, but it's a lot. And it freezes it on the way to where they stacked it, so it's incredible how they use the deep freezes. What else?
You want to jump to the T?
Yeah.
So let's show you the dry block and why ours is different than anything you've seen. So this is our MC6T, and set point is 60, so it's a little below ambient here. And this, with the orange wire, this is a Rio Temp beer probe. And the reason I bought it isn't because I'm making beer, but it was the cheapest probe I could find. It's about $50. So it looks like it's off by 0.17 or whatever. But our little reference probe is measuring 59.748. So actually, this is off by 0.3. And we haven't calibrated this in 3 years. But we really don't need to. Our traceability is this number versus this number. So, it's, to me, this becomes more or less a heater. And I could even go in and make this display match this. I could like calibrate this against that. And one of the things we're using with this is what's called ITS 90 coefficients. Have you heard, some of you maybe heard of that? But the science weenies, hey, in 1990, created the table of ohms versus temperature. And they came up with a 5th order polynomial to linearize the RTD signal against that temperature. So when you send this little white guy to us or to a lab to be calibrated, certified, the lab will give you coefficients to plug into the calibrator or any instrument. And you're basically linearizing any offsets and getting a pretty good number across the range. So that's why we're giving you 3 decimal places with this number. It's really, really accurate. It's really accurate out to the second decimal in terms of that. So for most of our customers, we're super accurate, but of course, there's people out there that want something more accurate, always. But I think for process control in general, this kind of information is pretty cool. So my beer probe is actually reading a 1/10 of a degree high, not low. So, and depending on the process, if you've got a reactor temperature or something kind of critical, something happens at the temperature, your control engineer wants these kind of numbers. They'd like to know. When it says 170 degrees or 180 degrees is sterilization, right? You want to see 180 degrees, you don't want to be off a degree one direction. So I've got a routine in here. This is our manual mode, if you will. But if I hit the home key here, it's the same menu as the MC6, other than this, instead of the meter mode, we have this special temperature calibrator mode. But if I go in here, I have TE 160 is this beer probe. And I've got a range set up from 60 to 160 using the reference probe versus 185, 100 per. And we're just going to do 2 points. So just that little lag time of no control, the temperatures somehow drops. The probes are pretty close, but in practice they're off a 10. But see this little signal here, our calibrator doesn't like the stability. It wants it more stable than it is right at this moment. So when that goes away, we'll take a reading in the automatic mode. But I'm going to go ahead and hit start.
So full disclosure, Ben had 3 points in there. I had him take it down to 2 just for speed.
What is the stabilization?
Well, I just hit a button to show you the stabilization graph. So it's trying to get to 60 degrees, 0% of the test range. And the blue line is the internal set point, and I'm going to guess the purple line, there we go. The purple line is the beer probe, and this red line is the reference probe. So here's that 1/10 of a degree difference, but this is the stability. So the stability is now under 1/10 of a degree for the last minute. So basically, when this blue line gets down here, it should record. And things are kind of stabilizing out. So the reference probe, it's already gone flat. We're just trying to maintain that temperature. But the reference probe and the field probe haven't stabilized. Well, they're all stable. So, Roy, if you hit the little graph button, let's tell it to go ahead and record. Oh, it's counting down. So I did put a 30-second countdown.
At this countdown, I would submit it's not as critical as with other drive blocks. Other drive blocks don't look at the stability like this. They look for a certain.
The ones I have look for 7 minutes or 15 minutes or something like that. You read.
Yeah. Well, it just beat and recorded. Now it changed the set point to 160. And Roy, if you go back to that graph, this is what I really like about our temperature calibrator, is you're going to learn how temperature probes react. The diameter of the probe makes a difference. So the beer probe's a 1/4 inch. It has more mass. So it takes more energy and is slower to respond than our internal reference probe, which is real small and down at the bottom, close to the source. And then the reference probe is a little slower reacting. But notice the stability is off the chart. So stability is greater than 1 degree. So as this gets close to 160, and it's only 20 degrees from 60, it's not even halfway yet. But Roy hit the change this, or he didn't hit the button. It recorded just before the 3-minute mark, and I'll go ahead and predict in 8 minutes we'll be at 160. It keeps up in about 5 minutes. It's pretty fast.
How about cooling down? Same on cooling down.
It's about
A little slow.
about 150%, so it might take 7.5 minutes.
That's pretty quick.
Wait a minute, you said 8, it's not start changing?
Mm-hmm.
Yeah, after that.
Cooling, but cooling slower. It's even slower, if you put in a negative temperature, you want to get below 30. Freezing temperature, it's even slower. And how many people have a temperature loop, 0 to something, 0 to 200 degrees, 0 to 500 degrees? But how often does that process ever get to 0? I mean, that's 32 degrees below freezing. Never. So it's like, why does the engineer care what the probe reads at 0? It never gets there. So you can save a lot of time by just calibrating it at 35 degrees. You can get there very quickly and show that it's accurate at 35 and show that it's accurate at inside.
Are you saying that if it's accurate at 35, you can assume it's going to be accurate?
In general, I mean, we're not going to see it here, but temperature probes should be parallel to perfect. If it's off a half a degree here, it's going to be half a degree full scale. If it's off negative or plus, it's always going to be just a 0 offset. If you have a probe that has an angle, you probably should consider throwing it away. It's probably.
Yeah, I don't agree with that. I think it changes with those the constants. You take the error at 0 and then times the constants, and it gets say it's a 1/10 of an ohm at 0, it gets worse and worse, like 3/10 of an ohm at RC.
Well, now I don't know what the ohms are. I'm converting to temperature.
Okay, 3/10 of an ohm will be roughly 1 degree C.
Okay.
And a 1/10 will be a 1/10 degree C. So it's a little bit off, it does increase the farther away from 0 you get.
I don't know how a probe that's been in a process, how it changes. I don't have experience with that.
I've had pretty good luck. They don't generally change. If you got them reading right at 2 different temperatures, you can pretty much bet that it's going to be good in 20 hours.
That's where we were talking about the loop test. If you can put those offsets into either your DCS, DLC, or change the 4 to 20 to match a perfect temperature, you've got a very reliable measurement across the board.
You said 0, do you mean Celsius? You're saying why did they do 0 Celsius or Fahrenheit?
Well, I have this probe set up in Fahrenheit, but
You're saying like why did they set it? Because I guess just thoughts on that is like ET100.
Because they were developed in Europe.
Yeah, well, yeah, SI. But
the 385 is German.
Yeah, because I mean it's 100 ohms at 0, so I guess they choose it as like their 0, their 0 point relative to that linear trait of resistance. Because they're not all linear. If you go, I guess, infinitely in the scale, temperature scale, that's just what we use.
What's a typical range for your equipment?
I can't just. I'd have to search it honestly. What would we say? 0 to 100, I'd say. Yeah. But even PRTs.
And how accurate does your stuff need to be? Is it within a degree?
No, yeah. 1%.
1%. 1 degree. So now, I just heard the sound change. So we're using PID to hit the set point. And now this gap is closing up. So as this guy levels off, these guys still have a slope, but they're coming in to temperature. But the stability still isn't on the stability.
I think it's got to come down to more.
Yeah, that's not. Here it comes. Here comes the red line. So the other 2 lines are still off. So when these 3 light lines get down here is when we'll record.
I'm gonna go back to the numbers just briefly.
Yeah.
Within 0.8.
So how is the beer pro connected to the calibrator?
I got a 3-wire connection here for the field probe. And this reference probe has a LEMO connector that you can just connect on there. We also have another channel for RTD, so you could do 2 RTDs at once against the reference probe. And if you have room, you can do 3 at once against the internal reference. You don't need super accuracy.
What was the kind of triangular warning symbol next to your reference?
Once it gets above 120 Fahrenheit,
Oh.
it lets you know that you can burn yourself. You can fry an egg.
Let's do that.
It's just a one.
Thank you so much.
This will auto range, so we're kind of losing it, but now it's looking really good. If you flip back, Roy.
And it shows we're 10.5 minutes.
And there's that 10. So we're showing the SART here, our reference, and we're showing that this is reading. It actually was reading high at 0, wasn't it?
Yeah. Yeah. That's dangerous.
Yeah, in 3 decibels.
Yeah. I didn't know we had 10 dangerous.
Ned, the percentage in red?
Yes.
37%?
Well, the range is 60 to 160, so this is 160 and 0 would be 60.
I meant
Percentage.
Yeah.
Oh, that's just saying that it's applying some heat right now. It's using a little bit of heat to raise the temperature.
Yeah, what is the 37?
37% power. You'll see it on the cooling as well.
I see, okay.
And then you'll see that number go down as it stabilizes.
So it would go to 100, it probably was at 100% when we started at 60 and now it's backed off. So this much energy is holding at 160. And it goes to, this one goes to 300. So, and I've learned that after you get about a minute of this, or really a minute of this, that's when it records automatically. So this probe's really good. It's off. It's even better at a full scale.
Can you capture that graph, or is that just something we're looking at?
No, this is a calibration. So we recorded these 2 temperatures here.
Now it's counting down.
In 20 seconds, we're going to grab those 2 numbers and you can upload that to CMX.
I mean, that graph that we're looking at, that's something that, can we, if some engineer wanted to see that, is that something we can?
Yeah, it would be on the certificate.
Oh,
When you
okay.
print it out, you can show them the graph.
Wait, you mean the other one with the lines?
No, I mean, yeah, I mean, the one that we're stabilizing.
Oh,
The other one, yeah.
you'd have to take a photo with your phone.
Okay.
Or with this tool, you can do it. You can snip a screenshot. You can snip it.
Oh, okay.
We're 10th of a degree off, which is 10% of our allowable tolerance.
So the $50 beer probe's okay. Not bad.
So it's better at 160. So kicked on because it's going back to the first test point. If we get out of the test or save it, then it will stop. Look at it, save it.
Yeah.
I know that.
One thing on this SIRT on the top left, that triangle with the exclamation point is telling you that you're using a custom curve. You're not using a standard Platinum 100 385, but you're using an ITS 3D or a counter-inducing set of coefficients.
stability.
You want stability? We can ask it. Good.
In case you're curious, I just went into the Blue Gears to check out this SIRT, that temperature probe. You can use this as a Platinum 100 385 generic, but if you do have the characterization curve, then it's going to be more accurate. So here are the ITS 90 numbers. Whoops, wrong. Here's our R0.
We'll go to 3, go back up. So that's the ohms at 0 degrees C. It's off by O2. But by putting that into the formula, it puts that O2 offset into the formula.
And all these numbers will be on your calibration certificate for your probe.
And they're crazy numbers. So there's coefficients for below 0 C, and then there's numbers for above C, and there's different formulas depending on the maximum temperature. So they're crazy numbers that we calculate. So you can make a mistake just keying them in. You need to double check it work.
What was the previous thing before 90? Was it 85 or something?
ITS 90, IPT
68.
68. Yeah, so they set the formula in 68 and then people argued about it and changed it in 1995. So I guess the only other thing to talk about is you could go into a calibrator and simulate the RTD, right? So we got it measuring, but if you were to change that to sim, right, maybe you can't sim. You have to do it on window 2. So when you're simulating, we'll show you the ohms. So simulate 32, right? Which is 0 degrees C.
You didn't want to work.
Yeah.
Maybe we should switch.
Yeah. Or yeah. I thought I hit 3.
So there at 32 ohms, we simulate 100 degrees. And if you did 212, you'd see 138.5. But I know a lot of you just simulate an RTD signal into your control system. And but when you do that, you're assuming that the probe itself is good. And like we said at the very beginning, sometimes you can't pull the probe out, you don't have access to it. Does anybody ever do a spot check on a probe? Like maybe there's a thermal well where you can compare the temperature? Who said yeah? So that's a good way to just say it's in the ballpark.
I've got a room temperature thing with a little bottle of fluid. I just do it at ice point because the temperatures I need are around freezing.
Yeah.
Wait, so that, the block is actually simulating the temperature?
Not the block.
Oh.
You should hit RTD at the top and tell it to stop. So now we're just using like the portable MC6.
Okay.
So we're simulating 138.5 ohms, which is 212 Fahrenheit.
From this connection. And where's Chris asked about leads. So we do have leads to use for simulating transmitters and these M12 connections. You can get different ends. So these two end up connecting together, but I wanted these banana jacks on one side and then bare wires. So I can plug the banana jacks into there for simulation, connect onto my wires on the transmitter, and now I'm simulating in the transmitter from the calibrator. There are several ways to do it, but this is one of them. Did I end up showing it to you, or did I?
Yeah, you should.
Okay. Anyone else want to see these? If you don't mind, screw those together.
Yesterday I ran into an issue where the jumper I was using had some solder on it and gave me bad reading. That's why I was asking about it.
Oh. If you have any of these Beamex clips, this, I call it fly legs when you squeeze it, these little. But when you flex this, the resistance changes. So do not use these for doing RTD work.
They're okay for milliamps, but
I use alligator.
But use little alligators.
You have problems with alligator clips?
Well, you need to have 4 wires. The leads need to be of the same manufacturer.
Right.
So they're the same gauge. And then the clips, if they're all the same, you should be fine. Or get some speaker wire, make a little bundle yourself. However you do it, as long as the resistance is identical is what you're after. But Solvay was using these up in New Jersey, and they were calling like, I just calibrated temperature loop and it's off. What the hell? You know, your stuff is so good, you know, and then we figured out it was due to this bad probe. So they were like decalibrating their temperature loops. And then, you know, we also have the device for thermocouple. So you can use bare wire for your thermocouple work. And we have one customer in Greenville. Have they closed, Torre?
No, they reopened.
They reopened. So Torre in Greenville has a certified S thermocouple that they bought from Burns Engineering. I have no clue what they paid for it. But they plug that into one channel on our MC6, and then they check their field probes against that reference probe. So you can buy a certified thermocouple. And does anybody know JMS Instruments up in Statesville, North Carolina? They're a good resource for temperature sensors. I highly recommend them. They can deliver certified probes as well. So, I mean, you don't have to have our stuff. In fact, we have customers that have spent a lot of money on their reference probes, and they can just put the ITS 90 coefficients into the MC6 and keep using those probes. Thank you, sir. So any questions on temperature?
It doesn't have a thermocoax like cables to use. Like specialized thermocoax cables, because obviously different thermocouples. Some of them are tough to reach.
You know what? There's a company in Virginia called ETL. So it's not ETL.com, but ETL Instruments or something. They make a coiled cable, like an old phone cord, that accordions or whatever. But they have the little clips on the end that are the correct material. So they have like a J set, a K set. I would recommend those for you guys, the way you work. So it has the little, it's an old style clip where you push the button on the back and it has a little hook that grabs onto a clip. It's called ETL. I could get it for you, email. Well, I did call up the data sheet, boy. It's on my PDF.
Oh, did you? Yeah, I couldn't find the one I wanted.
Here it is.
Yeah.
So this is a good example of how it explains which cables connect to what. So what I'm using is this one on the top left and then the bottom right.
Yeah, and this is a field reference probe that we make. And then anybody that's familiar with Amatec, we have a connector for the Amatec probes. They make some nice reference probes. Or, you can make your own connection, something like that.
Yeah.
So I think we're capped out. I don't know. Are there any other questions or any other things you guys want to see?
Or anything you don't ever want to see again? Actually, don't share that.
Did you bring us your beer to try?
What's the deal? Say again?
Did you bring us some of your beer to try? Did you talk about it?
Yeah.
Can I say something? Every time you said beer probe, I didn't hear a word you said for like 10 seconds. You would say beer probe, my mind goes blank.
I heard you say you're buying this beer.
Yeah.
That was in the revised schedule.
We actually have some beer in the fridge. Roy,
I brought it from Colorado. There's a 3% chance that it's legal here. I probably shouldn't have said that. I apologize. Hey.
Still live streaming.
What else, guys?
Wrap it up.
I think so.
Do you have the part number for that release now?
Go to the web shop.
All right, fine.
Okay, can you get us a senior citizen discount?
Oh, it's fine.
I can get you the klepto.
There you go.
Friends and family.
All right. That's not a number.
Yeah, we can respond to the site, sorry about that.
Is it possible just to have the site?
What's that?
Is it possible to have the parts site just sent out to all the emails?
You go to Beamex.com, we call it the web shop. It's our store.
8,009.
Oh.
Is that more?
But when you go to the web shop, by default, you might get the worldwide web shop.
Not if
There's a
you're
shop
coming,
USA. to
not
get
if you're
you on
coming
the-
from the US website.
What?
If you're coming from the US website, it'll bring you direct to the US
Okay.
web shop.
I will not fight that. So I guess that is a wrap. I was worried if,
What's the nomenclature for this, the low pressure pump?
It's also on the web
Yeah.
shop,
Just so.
but it is,
So
we don't have a part number.
Or just so I can query it, like what's
PGL.
PGL, Papa Golf Lima. Okay.
I want to play the first 20 seconds of this.
Oh, yeah.
Oh, yeah.
YouTube star.
No.
Are you
still recording the calibration information on pen and paper? It's time to go digital with Beamex's B-Mobile calibration application.
Yeah, so that's all I wanted to show you.
So, we're switching to this.
Oh, thank you. Was that first take?
What?
First take or?
Yes, it was.
Nice. I mean, I thought it could have gone over your head or something.
Yeah, that was the very first take. And so Heikki, these are one of our genius engineers, was down below, and we decided I'm going to throw this stuff. Or actually, I didn't tell anyone. I just did it. And then he throws them back up at me. I didn't know it was coming. He didn't tell me. But we tried it like 7, 8 more times after that, and it was never as good as the first one, so. There are demos on that as far as B-Mobile, to show different examples, but aside from that, anything else before we close up? Yeah.
You mentioned then about the B-Mobile that you were in Colorado. I was around here. That story.
So Antonio, so I'm B-Mobile using CMX. I was in Colorado. Where were you?
New Jersey, I think I was.
You were in a hotel?
Yeah.
You were in a hotel, and I logged in and I downloaded a couple tags from his database in New Jersey. I did a test, and then I uploaded it from Colorado back to New Jersey, and then he printed out the calibration certificate. So that's one of the cool things that you can do with B-Mobile. You don't have to be in the same place. Thanks. So it has been a pleasure. I think you've learned some things that you wanted to learn. You've learned some things you didn't want to learn. Yeah, sorry about that. I told you I would offend somebody. I do want to get, are we going to send out a survey?
Yes. I'll put up the slide.
Okay, that sounds good, because we do want feedback. This is something brand new that we've never done here before. It's been done in Europe and I think a couple other places recently. So you guys aren't like guinea pigs. They're given as test subjects. You are test subjects. This is number 1. And we need to know what you guys want to see. We did do ACE, and we heard back that we wanted more technical information and that. So we appreciate that. Finally, in the words of George Carlin, probably one of the smartest guys that ever lived, take care of yourself. Take care of yourself and take care of someone else. Thank you very much. You really did say that, by the way. I'm gonna go get my injection.
Did we want to let them know? Oh, yeah. No, we're just focusing. Hey, guys,
You too, sir.
right now, your PD certificates, you will get those and your survey in your email on Monday morning. So enjoy your weekend, don't worry about it, but remember all of the good, bad, or ugly things you want to say about Roy. The good things about us. I know, we definitely ended up not really enough with all the sizes, that's my fault, I saw the people. But if you want to, sure. Yeah, absolutely. Send them up there, you guys. And then I looked at the restaurant listing. You're good, you're good.
Nice to meet you.
Turn this on.
This is always a